Good sodding human. Wait, I spelled it right. I said soldering. What's up, man? You? Yeah, soldering. Okay, you're just spelling it. Okay, I'm here. I'm here. I'm alive. I'm alive. I'm here. Oh, jeez. Crazy couple days. Did a whole bunch of the forest, the Sons of the Forest yesterday, and we discovered that it's not so much a survival game where you're supposed to like build a base. It helps to build a base because then you get clean water like from rain, but that's not really that necessary. We found out because we started just going from thing to thing to thing and just collecting stuff. We were like, oh, I want this gun, I want this shovel, I want this piece, I want that piece. And when we started doing that, we discovered that that game, your inventory is fixed. You have variable things like the amount of sticks that you can carry, but that doesn't really matter if you're not building a base. If you just keep jumping from thing to thing to thing, your whole inventory is on you your whole time. You'll max out on certain things, but our survival was so much easier because we were coming across energy drinks everywhere we went, and we were coming across bullets everywhere we went, and we were coming across supplies everywhere we went. So if we just went place to place to place to place, we were just kind of rocking the whole show. So we really kind of tipped the scales on the whole survival thing. It was a very interesting time. I guess they had a different philosophy with how survival horror would work in that game. They decided that instead of turtling, you could just be nomadic. And we were sleeping at like campsites, which was perfectly fine. You know, like abandoned campsites would have all the supplies we would need, and then we just sleep there and then continue on to whatever else we were going to get up to. It was a totally different game at that point. Whereas before we were doing our usual thing of like splitting up and like, you know, getting wood, getting this, getting that, getting the other thing, and bringing it all back to one location. It's like, that's not necessary. We don't need storage containers. We just have, you know, go as we go. Just put a tarp down if you need to sleep. It was crazy. It was a really, really interestingly different kind of survival game. Different kind of survival. Of course, once you have something that's like no longer a useful weapon, like a spear is no longer useful because we have guns. It became a little weird that it was always in your giant inventory the whole time. You're like, I have 7 spears. Like, what am I doing with these? I only need them if I run out of stuff. So over the weekend, I did a little bit of work. I did a little bit of work without you guys to try to start figuring out, start sussing out exactly what's going to go into the module tester module. We know what all of our hardware elements are, and I've started to make the stack, where we stack boards on top of each other to make all the different functional pieces of our whole circuit. And there's still a lot to figure out. It's going to be a little bit janky, but hopefully it'll go together nicely in the end. Yeah, it's basically going to be that and then this. I don't even know what's going up here yet. I gotta keep all the pieces together though, because I don't want to lose my scheme. How's everybody doing today? Oh, this is one of the ones that I killed. This is one of the ones that I killed. I had way too much food for lunch. We'll see what my glucose levels are doing. I gotta check in on them mid-afternoon and potentially inject myself with tons of insulin to compensate for the amount of carbs that I have running around my body. That's 2 of these voltage regulators from Pololu that I've completely destroyed, including damage directly to the chip. Unfortunate. Very unfortunate. I don't know what to do with them. They were like 20 bucks each. No, they were like 10, but they're still like precious. The other thing is I want to do through hole with sockets, but particularly for the amplifier section that comes out of these. First of all, I don't have a lot of room. There's going to be a lot of potentiometers. Secondly, there might be room for a socket underneath this with the TL072 in it, but I only need a TL072, not a 4, and these are 4s. Well, these would be the size of 4s. I mean, TL072, I could cut the socket. I've seen that done before. That may be the way that I have to go. Because I don't think I have sockets for those. I got rid of all of them because I figured I'd never need sockets. But in a device like this, you know, hey, anything could happen. I might blow up a TL072. And if I do, I really don't want to repair a dead bugged or live bugged surface mount one. We'll start with the power supply, though. That's really where things start. We start with the power supply, and for that, I've got a whole scheme of what I want to do. It's going to be 3 potentiometers per voltage, and then we got to figure out how we're wiring up the negative power supply. Which, you know, honestly, maybe I should just... man, that's so, I don't know. I could replace the microcontroller in these circuits, in this. And then it could be using the low side amplifier that we bought. And, you know, I already bought the expensive chips. I probably didn't have to if I just bit the bullet and replaced the microcontroller. But then I could program the small microcontroller to do the muxing of the display and display the numbers. And then I would be able to tune it just with 2 voltage levels. Assuming it's linear. I think it is. I think I have AT-Tiny 13s in here. Shock diode. Come on, where is that? Voltage regulators. Op amps. Here we go. AT-Tiny 24 is the size of that chip that's already in there. That would be a little bit of development, though. I'll keep these on top just in case I decide to have a mental breakdown and go into that yak. That's a totally different yak, though. Because that would mean that all I have to do is... what do I have to do? I would have to... measure the voltage output, figure out what that breaks down onto a 0 to 1024 scale, possibly by setting up one of the AT-Tiny 13s on a test bed and having it just spit out the number that it's getting for me. Which is easy to do with the Arduino. That's easy to do. And the Arduino core for the AT-Tiny. And then, what else? I would have to get the 2 voltage levels for the 2 different current levels that I can do out of this thing. And that would give me 2 numbers. And those 2 numbers, I would assume linearity on. And then I could probably test it against itself to give me a 3rd voltage level. Because I can do 1, 2, 3. I can go all the way down to 1 resistor, which is kind of dangerous on that setup because it gets kind of hot with 12 volts. But that would give me a spread of currents at that voltage instead of jumping from current level to current level and adjusting these things like it's an oscillator. Because it's like, if it's not linear, I'm shit out of luck. I'm trying to fit a line of best... I'm trying to do a line of best fit on something that's not linear. I think it is linear, though. And if it is linear, that means that all I need to do is play with that number line from current to current. I don't have a sliding scale current meter, though. I don't have like a rheostat that I can put on it. I guess I could probably try putting a potentiometer on it and see, like, plot the levels and see where it goes. Oh, God. It's all so much work, though. And I don't know what pins go to what pins on the display. But, I mean, treating this as its own, like, PCB thing, its own layout. And all I have to do is give it a brain that'll speak my language. Which is what we did with Julian's reverb module. His Erica Synths reverb. It used an ASIC that creates reverb, and then it had a microcontroller controlling that. And so we just figured out what the code would look like, assuming microcontroller. Since this thing is getting its positive and negative on these end pins, you can see that the positive 3 volts is just going right to pin 1. If we look at how the AT-Tinys are structured, this is an AT-Tiny 24. 24, 44, 84, it don't matter. These are low power, not that capable. They're okay. They don't have a lot of pins. So as a digital signal broker, they do really well, or in a singular function device. We turned ours into a motor controller for a simple DC H bridge. And it didn't quite work because of the MOSFETs that I chose. It would have worked as a regular old one, but the thing about AT-Tiny, the SOIC version, is that they put power and ground on opposite sides, pins 1 and 14, which is unique because the PIC microcontroller puts them in the middle. And your typical thing is VCC in one corner and then ground in the other. So in this case, we have VCC and ground on pins 1 and 14, which is the way that our current sensor does. This is actually a ground pin right here, and it just connects back to ground. So we have two analog input pins, which are pins 13 and 12, which again lines up with ADC0 and ADC1. Evidence is stacking. One pin is left floating. Pin 4. PCN11 reset and DW. So the reset pin is left floating. And then from there, the remainder of the pins are dedicated to running the display, which would take a little bit of research to figure out what kind of 8-pin. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9-pin, 2-digit LED. I forget what these are called. Hey, Kagas, how's it going? I'm just kind of brainstorming right now because I can't stop thinking about this. This is one of those projects that just kind of infiltrates your brain space. The silicon still hasn't cured. What were you doing with that again? I'd have to read back. I've had no memory of such. I had a surprise LAN party yesterday. I forgot that we were having a LAN party, and so I ended up 2-digit LED display module. AliExpress. I just want a data sheet. These are expensive for what they are. So those have pins on both sides. I need pins to be on one side of the display. Let's see if we can just Google image it. Oh, you know what? 2-row. Oh, and it's more than 2 digits. It's 4 digits, isn't it? I'm dumb. 3-digit. 3-digit. Cooling an ESP into a 3D printed case. Ah, why with silicon? I guess that's the safest stuff you could use. It's hot glue works too if it's, you know, depending on... I guess you're trying to make it like environmentally sealed. This is where the mix gets a little weird. I'm going to turn it down a little bit. I'm going to let this mix get over its like K-hole or whatever the hell's going on. I got to check in on my glucose level this afternoon, and I can't forget to do that. It's all you had. If it's all you have, it's the... Yeah, that's the best bet. 7 segment... Oh, I see. Wait, 7... Oh, yeah, because it's 7 segments. Visit double row, 7 segment, 2-row, 2-color display. Can I get a data sheet? How do they expect us to buy something like this without a data sheet? Oh my god. Do I not want to chat with your AI? Whatever. They try to give you an impression that somebody's sitting behind a computer waiting for someone to open up their website so that it can chat with them about a product. What, like, can I get a part number? No, it's just got some terrible... Yeah, they don't want to give you the part number so you can't find it on DigiKey. So two row, 7-segment display. Say dual row. Yeah, I guess I can do the, I wanted to avoid that. I wanted to just find it. What's this one? That one has, yeah, pins on both sides. Finding the ones that's just pins on one side is going to be a little bit more difficult. So let's just do DigiKey. 7-segment display. Bonk. LED character numeric. And then we're going to go to number of characters, 6. Seventh segment. Wavelength, power disk, package case color, alpha size, number of characters. I guess we'll just try that one and hit apply. Those look cool. 1,000. Okay, let's keep moving. It's supposed to be a 7-segment LED display with 2 rows. Wow. Hey, Poopsie Doodle. All right, let's redo that. Maybe get rid of number of characters, I guess. Just do 7-segment. Apply. 3,000 results. Don't know about series. It's going to vary per manufacturer. Wavelength, power dissipation package. This is not as many selections as I thought there would be available. These are all singular. That's 2. I need 3 by 2 rows. Three by 2 row in order to figure out what we have. Is there a part number on it? Oops, wrong one. I have to get it out of here in order to see. I don't think there were any markings on the sides, though. I don't know. Apparently, this is a heavily specialized part. This might be the mix that I really don't like. No, I guess this is okay. We can let it live for now. I may have to move the fan closer. It cooled off around here, and so it's like really, really nice weather. I can take the PCB out, but I don't want to do that right now. I'm just, look, what I'm doing is I'm vetting to see whether it is worth it for me to try to reprogram the microcontroller to have my own code on it, and that way I wouldn't have to do so much tuning when it comes to figuring out how much current corresponds to how much voltage out of our circuit that we're replacing the high side with in order to have a low side driver. Hold on, where is that? It's basically taking this product and fully reinventing it. I had been adjusting R2 and R1 as potentiometers and getting all kinds of different results. And it was a lot of like wiggling back and forth between current levels and voltages. It might not even be linear, but what I could do is reprogram the microcontroller and have it in a state where it can communicate back to me what it's seeing in terms of voltages as its own numerical representation for the ADC. And that way I could program in a line of best fit for the whole thing. You know, I could do a little plotting and figure out exactly what that curve looks like with the resistance values that I give it. And then I wouldn't have to do so much tuning. And it would be close enough that it wouldn't matter. This isn't a super duper scientific part of this piece of equipment. I could just put this to bed without having to sit there and adjust it, or I can weigh that against how much effort it's going to take me to sit here with my load cell and hit it with 2 or 3 different load amounts, and then tune the resistors to those and get it close enough. I think it kind of struggles on the milliamps though when it comes to that. But like we almost fully reverse engineered this, so. Where'd OBS go? There it is. Because like which one corresponds to that? That goes there, and then that goes there to there. So pin 13 is voltage. Pin 12 is this thing. Pin 4 is not connected to anything. Oops, no, we do those outside. And then pins, it looks like pins 2, 3, 5, 6, 7, jeez. That's a terrible 5. Hopefully I can read that again. 2, 3, 5, 7, 8. Nine. Pin X and then pin 9. Close enough. I don't think we tested it, but it does look like that one does a little leap. I could just do an ohms right now. This might be useless stuff that we're doing. That's why I'm doing it during the intro. I'm just thinking about it. Get ohms out here. Test between here. Oh, it's not even on. Come on, turn on. I got good sleep last night, though, because the temperature went down. Oh my god, I slept so well. I feel great. That is incorrect. That is not the pin that it goes. Oh, wait, no, this would be it. Oh, yeah, that is the pin that it goes to. So it's 2, 3, 5, 9. Oh, God. No. 2, Jesus Christ. Okay. Hold on, let me start this over. And I'll zoom in so that I can write a little bit more clearly in here. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh god, I'm not gonna fit that. Let's go with a smaller pen size. I just want to jot this down while I've got it. It would be kind of cool to go in there and take over the micro. 1, 2, 3, 4, 5, 6. 7, 8, 9. All right, so we'll do it from pin 1 being over here. I just don't know if that's the case, but who cares? So pin 1 is, I don't see anything connected to. That probably gets voltage on the other side. 2 goes to pin 2. So let me just, hold on, I'm doing something. 2, 3 to 3. 3 to 3. 4 to question mark. That's probably power and ground, who knows? Or that's another Banks. Or maybe it goes to a via under the chip. Five to pin 5. Oh, it works out weird. 5 to pin 5. 6 to pin 7. Six to pin, wait, 1, 2, 3, 4, 6, 6 to pin 7. 7 to pin 8. 9 to pin 7. Sorry, wait. 8 to pin 7. 9 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 to pin 9. There we go. Okay. What's the device? It's a current meter, and I'm debating with myself whether or not I want to reverse engineer it and reprogram it, because it seems like they're using an ATtiny24, although ATtiny24 might be too expensive for this sort of thing. It does look like it probably is an ATtiny24. I don't know what the voltage input limits are on an ATtiny24. If it can take 10 volts, because this goes up to extreme voltages because it's just a little voltage divider on it. They might just be lying about how much current this thing can sense. That or they're using a different microcontroller that has different specifications. But either way, I'm having trouble fitting our low side current sensor voltage. Our high side current sensor voltage is ill-fitting to the curve of whatever voltage it would get in under this circuit. If I can get it close, that's fine. I just don't want it to give bad impressions, where if it's drawing 600 milliamps, I don't want it to say 1.8 amps. I don't want to have to do math in my head and remember that the thing is wrong. I'd rather have it actually just fit the line of current to voltage. And so if I program an ATtiny24 to output serial, then I can look at what the numbers are that it sees on its analog converter, and I can get a line of best fit that way. And then I can program that into the two modules and have them, I don't know, maybe that is too much work. Maybe that is too much work. Maybe. The other way to do it is to figure out what the ratio of the resistors here is supposed to be from R2 and R1, as well as I actually put in a resistor here, a potentiometer there, in order to work on an offset and just the two variables, which I believe that this transfer function isn't quite correct, and that, well, RS times R2 times 1 over R1, you know, it's like, I don't know, I feel like one of them is dividing, the other is multiplying. So I think you can do the slope and get that to fit with an offset. But I'm flying blind when I do it. Basically, I take it to one extreme and I fit the two things, and if they don't fit, I'll try something to get it to try to fit. I think I don't know, I'm not able to sweep through voltages. I don't think I can do that. I could put a potentiometer in there, but then it would be like, I don't know how that would, I don't quite know how that would work. Because if you vary the load, you could get a slope, and you could see how that compares to the slope of what it expects to see. That's why I have this here. This is what it expects to see. So if I tune this, and then I sweep it through different currents, I could figure out what the slope is and compare it to whatever this slope is and try to get that the same, and then I wouldn't be flying blind. Is that less work than putting together a display with an ATtiny24? Arduino has all kinds of alphanumeric display code libraries that I could utilize. I'm just trying to find the data sheet for the display that this thing uses, because it's a 9-pin display, and it's 2 rows and 3 digits. I just don't know if DigiKey has anything like that. Two-row, 3-digit, 7-segment display. I'm thankful for those who create libraries. Yes, they are very helpful. I also, the people who make libraries for very specific hardware. The problem is every single one that I've found of these things is 2 rows of pins. And we only have 1 row of pins. I was able to remove this quite easily. Like, how specific is that? Nobody wants to give you a data sheet either. This one. Two sets. What the heck? How do they do it? Seems like the kind where there's like a row pin and then a segment pin and then, yeah, I don't know. A lot of muxing going on. Just not as common as you'd think, huh? They got a certain look to them. What's being said? Nothing. Okay. Nothing. 7-segment displays, I guess, are still around, huh? There's a lot of other display technology out there. But nothing beats an LED. Nothing. Although nowadays you can just get OLED displays. You can do all kinds of cool stuff. You can overcomplicate everything. Everything can be super duper complicated and nobody will ever know how to reverse engineer your stuff. And at a certain point, I should have just made these from scratch, but it's nice that this thing has kind of the presentation of being panel mount and everything. I just really wish I could find any detail on this specific display. I don't think there's a part number anywhere on it. We removed it at one point and we took a look at the front and the back. I don't have those VODs. I mean, I do have the VODs. I could probably open it up and take a look, but I don't know when it was. I don't know how long ago it was. Nixie tubes. Yeah, it's high voltage. It's that glow and the heat and just everything that it brings to the table. It's sort of that old world charm of it being sort of an initial technology that has a certain look to it. It has kind of a warm glow. It's comforting. But you can get 5-volt to 60-volt modules. They're just little modules that you throw down on a circuit board. It makes it so much easier to work with them. And then you can also do BCD to Nixie tube directly. It's a Russian chip that's an ASIC specifically for Nixie tubes. And that simplifies making a Nixie display tenfold. It just makes it so easy to create any display. Two-row, 3-digit, 7-segment display, 9-pin. That's way specific. Way specific. All right, come on, dox me. I guess it's not going to dox me. All right. Do I need help with this common cathode 9-pin 2-digit 7-segment 2-digit? See, I have 6 digits. Did I say 6-digit? 2-row 3-digit. Yeah, I don't get 2 rows when I say 6-digit. The closest I got was that initial search with the 2-color one. There's one in Estonia. I've heard of a couple of them, but I don't know how they've done with all of the spiciness over in that area of the world. That one's a 3-digit. That's half of what I have. It's half of what I can accomplish with this $6 part. Well, $6 entire display. I'm not describing it right. It's just something's not clicking with that. Like, this is as close as I've gotten so far, without L1, 2, and 3 on the side. But they're squirrely about the details. They're not giving me the information about what it is. Model number. Maybe that'll help. LEDscreensign.com. Datasheet. No datasheet. Why do you not give a datasheet? Is it not enough? Can I not get a datasheet? Some 386 buried in a closet spools up in order to give us this web information. This isn't a parts website. What is this? Nothing else. Plus, the pinout is a little sus. Damn. The part number is useless. Yeah, SEO destroyed the internet, indeed. It really has. It's like, I used to be able to get so deep into these searches that I would end up on pages that were just like township directories of like alphanumeric codes that were just like completely beyond like what I was actually looking for. But nowadays it ends up with like, we'll sell you any part number. I don't know what that acronym is. Dead internet theory is sort of the going. We need GeoCities. We need something. Need some of that original internet back. Those internet 1.0 websites where you know that the information on there is simply there in order to convey information. All those engineering like circuit websites and stuff like that you used to be able to find. Some of them are still around, and I hope they stay around for a lot longer because there's some institutional knowledge on those web pages that's very important to me anyway. Very important to me. This is weird. This LED display is weird. It's got fewer pins than any other one that we've seen, and yet it has more digits than any other one that we've seen. I would assume that maybe it has some kind of a digital protocol to it. Maybe it's I2C. You can torrent GeoCities. How big is it? Is it like 60 gigs? I've probably downloaded movies that are bigger than that. Legally. I2C 7-segment display. I would assume that it has to be some kind of a digital protocol in order to carry that many digits. Dual row. It is enough pins for SPI. Let's put SPI in there. Maybe we'll get better results. SPI. I wish it resized to the page. Instead, it insists on cutting off. It's like it's SPI and it's 2-row, but it's its own circuit board, so that's not really what we're looking for. There we go. Let me see. What could it be? Is this your display? None of these are what I'm looking for. This thing is a unicorn part, which I guess kind of seals the deal on it being. I'm not going to sit here and plug into all of the pins and see what's running around on like digitally to the display in order to reverse engineer some kind of SPI protocol that probably already is in a datasheet somewhere that we can't find. I'm not going to do that. That's way too much work. What's this? 4-digit 7-segment LED blah. Yeah, I'm not going to do that. But like that would be the next step if I had to replace the microcontroller on this thing. This thing is so cheap that we've already done more work than the display's worth. the time, my time versus money. What would you use that on? Jeez, that's weird. It has to be some kind of digital protocol, right? There's only 9 pins. Maybe ChatGPT will find it. Shame on you for suggesting that. Go sit in the corner for 10 minutes. Shame on you. You know that's not true. ChatGPT just simply lies. AI is fucking useless. It's worse than useless. It's actively dumbing us all down. Copy equals lying. Are these 9-pin? They're more than 9-pin. Although 1, 2, 3, 1, 2, 3, 4, 5, and then you have 4 more pins. Oh wait, 6, 7. That doesn't work. I just don't know. Nine-pin, 7-segment display. 9-pin, 6-digit. This has 2 3s. That is way more pins. That's 14 pins. I could start using quotes to try to really narrow it down, but what's the face look like? So it's 1 unit, and it's 6 digits with 1 decimal place, and it's not alphanumeric, it's just numerical. And it only has 9 pins. There's that row of pins at the bottom. 1, 2, 3, 4, 6, 7, 8, 9. Only 9 pins, numerical, 6 digits, 2 rows. It's like a freaking unicorn. Oh, and it's bi-color. These are 2 different colors. It's red and blue. I'm not working on the project. Every single stream, somebody does this. Would you guys rather this, or I just put you up on like a splash screen with some kind of an image on it? I may have to do that. If people keep asking about it, I can't have my little hangout sessions with chat where I'm like just talking about whatever. This is a little bit more project related than I normally do during the intros, but it's not exactly what we're doing today. That was your first message. You are correct. I'll go easy on you, but there's always somebody that asks. Every single stream. And like just one overlay is not going to be unique to one user. So if there's something flashing up on screen that you don't see on any other stream, it's like something I've created. And so it's in OBS and everybody sees it. You can be rest assured. Wait, this one has 1 row. No, it doesn't. It has 2. I thought I only saw 1. I'm baffled about the protocol. Like, how do you do 6 segments with that many pins? Hey, Chimera. There has to be, yeah, like some kind of a protocol. Has to be some kind of digital protocol. It almost warrants hooking it up to the oscilloscope and listening in on the pins and seeing what's being communicated. I don't think I'm going to do that, though. I think I'm just going to leave it as it is and use the potentiometers to adjust. This song's actually awesome. Segmented LEDs are all about black magic. No, there's got to be like a library for something like this that would drive it. It's not necessarily LIAC magic. It's going to be like, you know, the data sheet's going to spell it all out for you, and then you can probably find somebody who's done something similar. I refuse to be cautious or change anything that I do specifically for your situation. You're the one that's going to have to change your ways in response to what I'm doing. Do-do-do. Do-do-do-do. I don't get it. Usually they give you control of all the individual digits, and it would be nice if I was able to actually make the display, like if I was going in there with a microcontroller myself, maybe I could make it display on camera a little better, because as it is right now, the digits don't like to sync up with the shutter rate of the camera. So if I had individual control of all of the all the digits, that would be great. And then I could leave them illuminated instead of being muxed in the way that they are. But I don't think that can be, I don't think that's possible. Especially with 9 pins. I think with 9 pins, you're probably sending it a string of serial commands, and it will display what you've told it to. Do-do-do, do-do-do-do. I had a big lunch. I hope I'm not going to be irpy today. If I'm irping, I'll take a break. I also have to check my glucose level in the middle of stream because my my stupid glucometer is not going to keep up with the big lunch later in the afternoon. I'm going to have to manually bolus myself like 1 billion units in order to pop it back down. Yeah, you think it has an integrated driver, like a Max driver? Because I don't see a single one of these with many digits and only 1 row of pins. See, they've all got that second row of pins except for the one that I have. Where did they find this thing? Maybe they made it themselves. Maybe I need to look at something a little bit more general about how these displays are run. Either way, okay, so the bottleneck is our figuring out what the display is and how it works. So that in and of itself puts that to bed. The thing that I was trying to vet out that none of you guys saw, that nobody's following along with, is that I was seeing whether or not I could replace the microcontroller that runs the display. And that is a ATtiny24, given that power ingress is on pins 14 and pin 1. So because those are the power pins, and because the reset pin is isolated from the PCB, I think I can safely, if not slightly unsafely, say that this is more than likely an ATtiny24. Now, the ATtiny24, given that this thing can sense voltages that are much higher than like 12 volts, they can go up to like 44 volts, that would mean that with the voltage divider that they've given it, it would actually be something like 10 volts going into the ATtiny24. I don't know if they can tolerate that. Let's just check that real quick. You can post the link, but I think we've kind of moved on, unless you have that specific display. So what are the tolerances of the Tiny24? This is the Tiny24 datasheet. It's enormous. It's like a 500-page. How many pages? 196-page datasheet. Now I don't want to. It's all right. It's all right. 2 timer counters, 16-bit, 2 PW channels, 10-bit ADC, single-sided channels, differential ADC channels with programmable gain, temperature measurement, Wow, that's nice. Analog comparator, analog comparator. Nothing about like high voltage tolerance pins. Hmm. Port B. This song rules. I like this song. Port A pins are externally pulled low with source current if the pull-up resistors are activated. Port pins are tri-stated with a reset condition becomes active. Port A is an alternative function as an analog input for the ADC analog comparator. Timer counter SPI. Alternate port functions. I don't care about the function. I care about what it can tolerate. Because I don't think it would be an over-the-top style driver. And it should just go to 1024 when you get up to VCC, which is 3 volts. So I don't know why it would, why the voltage divider would be structured the way it is, unless the voltage meter is, they just lie about what it can actually take, or it's not an AT-Tiny 24, it's some other specialty microcontroller. Kind of want to make a real Nixie clock. A lot of innovative knockoffs for Nixie displays, but cool people really want the original concept display and a clock without paying crazy amounts of money. Yeah, I was saying earlier that there's a specific Russian chip that can take binary coded decimal in, and it does the high voltage switching to display Nixie numbers. And then there's also, you can buy on like eBay, power supplies that take in like 5 volts and create the 60 volt DC that's needed to make the neon lamps glow for the Nixie tubes. It makes it so much more trivial to create something like a Nixie tube display or clock. A fiber laser and a galvo to delid the unknown. I have 2 galvo motors. I don't have a fiber laser though. I could source one, but I don't really need to delid all that often. Plus, the last time we delid something, it was a while ago, we used a razor blade in my vise, and then we used the milling machine to spin the can, and I had a pair of vice grips locking on the razor blade. I had my machine vise locking on the vice grips, and then I used the XY table to advance just a razor blade in order to create a cutting edge to decan a laser diode. And we had that light up too. It was pretty cool. That was a while ago though. So they didn't give me min-max conditions, did they? Oh my god, it's in here somewhere. It is not a small data sheet though. Where does App Mega put its electrical characteristics table? Need versus want. All right, true. All this for an AT-Tiny 24, huh? Oh my god. Oh, these are the processor instruction set. Oh boy. Ever want to do machine coding? I'm not using Control F because it's going to come up with 10,000 results. Yeah, nothing. Circuit diagram, logic table defines the electrical parameters of the reset surgery. No. Electrical characteristics, page 155. All right, I stand corrected. You were right. Using Control F was much more efficient than I thought it would be. Output high voltage. Input high voltage reset, input low voltage, output high voltage, input leakage. Where's my maximum analog input? IO pin, power supply current, 0.4, 0.5 milliamp. Analog leakage, speed grades, oscillator accuracy, clock drive, ADC characteristics, 10 bits, gainer, offset, clock frequency, input voltage, VIN, ground to VREF voltage. Where is VREF? Back to the pinout. We're like 75% through the datasheet. Jeez. VREF, I believe, is internal, isn't it? External crystal, PCN11, clock A, MOSI, ADC, ADC, ADC. None of these are VREFs. I think it's internal only. It's like a different pinout might have a VREF. So where's our VREF in here? VCC and ground. ADC. Analog comparator, which goes from those two pins. Well, I guess it's whatever pins, but yeah, I don't know where it's getting it from. Fuck, it's such a difficult data sheet to get through. So, all right, so what that tells me is that it's way too much trouble to try to replace this microcontroller because I'm having enough trouble finding the goddamn screen part number. If I could find the screen's part number, we know what the pinouts are, we know what pins are connected to what on this board unequivocally, so aside from 2 of the pins from the display, which I could figure out pretty quickly. And that would mean that I would be able to try to find like an Arduino project that would allow me to take over the screen and use the screen, and then I could somehow display the variable of the current level, sorry, the voltage level that it's getting in on its input pin. So on the input pin, it gets a certain voltage level, and then I could plot that out to the two or three different levels that are expressed by my load cell. And then I could take those values and I could plot them and I could do a line of best fit. And then that would go into the microcontroller so that it could then translate the variable that it gets in on its analog line. It could translate that into voltage and current, and then I would just set it for a display refresh rate that's kind of slow, and that would be that. That would be then a perfectly matched low side to high side conversion on this part. Now, if they were just a normal seller, they would probably have a high side version of their low side current meter, but they don't. I've looked everywhere. So we're kind of on our own. We're kind of on our own. And yes, I have already eaten crow today. I eat crow quite often on this stream. I have a particular set of opinions that I need to amplify in order to be a streamer, to have personality in this game and not be just a fence-sitting, lukewarm, personality-less engineer. So I will come at you because I'm from Philly. I'm going to clap back at you. I'm going to give you the clap. That's the wrong. That's not how you say that. That's not the right phrase, is it? It's actually, that's different. That's a different thing entirely. Boxes and boxes and boxes of things. What is that about? Wait, I gotta see this one. See it to believe it. Something's clapping. He's lived outside of Lansdale. Nice. What is in Lansdale? I'm trying to remember. I think I just drive by Lansdale. It's a banana. I'm a banana. Yeah. Okay, this goes there, this goes here. That stuff goes somewhere. Let's get started. I could show you guys the error, the weird thing that I've been dealing with, or we could just start building this stuff. I think we should just start building this stuff. All right, so let's fade out here, the music, and let's get started. It's a banana is a great comment to just start your stream on. Yes. I'm feeling fat and sassy. All right, let's get this start soon out of here and actually start the stream. You can see a difference in the way that I handle the stream from when it starts soon and when it's not. And everybody does this. Everybody does this. It's just I happen to have the cameras going, and since I'm an engineer, I always am thinking about the things that I'm working on. It is an affliction. It's how we work. I can't just talk about random stuff at the beginning of stream. I actually like deeply the people who can do that and make it very interesting. They have like hour-plus long intros, and they talk about whatever, and they just have a great time doing it. I love that. I mean, that's what it takes to do like a morning radio. You guys had a hair in your face. That's what it takes to do like a morning radio show, and it's actually kind of a powerful skill set, is just to be able to talk about random stuff, make up stuff, have fun, just being original. And I work on that. I actually do work on that a little bit. I try to find a couple topics before streams and kind of think about them and bring them up during stream. Most of the time, though, here it's a little bit more organic than that because I haven't done my homework. I'm terrible at doing homework. I've always been really bad at doing homework. What we're working on this fucking, I don't know, year, it's been a lot of work, but we're getting there. We're actually starting to round the bend on all of our different yak shaving efforts, and things are actually starting to kind of plug into each other and work out. What we're building is a module testing module, and the point of this thing is so that it has a power supply and it has its own module testing module, and we're able to pull modules through different test elements, like for instance giving a voltage to an oscillator and reading back what the note is that it's getting from that oscillator. So when you're building a piece of test and measure equipment, it really would be useful if it could measure itself. And since we are in the 21st century, there's a lot of tools for us that we can use in order to gain a little bit of accuracy on the back of geniuses that put these things together. So what we're really doing here is we are putting together a bunch of modules that we know are effective, and we are making them do the jobs that will make this synthesizer tester work. Now, because we're not going to sit here and author a specific PCB and make a product, we can take a little bit more of a loose sort of approach at this thing. We're not looking at individual chips that we're just going to include on the rest of our board. We're looking at modules that we can put together quickly and get the results that we're looking for. So what I've done so far is I have built this module testing module case where this thing is going to live. And I do mean live because we found out that the amount of circuit board that's going to be required to make this thing is quite heavy. There's a little bit of room on the circuit board for the backing of this thing. And to be honest, if I decided to take that approach of buying all of the components original and soldering them down on their own pads and just copying all these circuits, I could probably fit it on the button circuit board and one behind it. I could fit it on that, and then it would be like $100 for the big circuit board, and I would have to solder everything together and then get it all tuned individually and make sure all the hardware is vetted out. But I really don't want to do that. I think we can take a little bit more of a loose approach to this and have a lot more fun putting it together and just getting the whole modular synthesizer to function. So we've been working on the power supply, and what we learned is that it's very easy to go out and cheaply buy these voltage and current monitoring displays. You know, EVs use these high voltage batteries, and they use a lot of current. So these displays are very cheap, and we've been able to source 3 of them for like $11. Isn't that great? The only problem is the power supply that we're dealing with does not function. It doesn't play well with these displays. The problem with these displays is that they use what's called a low side current monitor. And when you do low side current monitoring, because V is equal to IR, the low side current monitor only requires you to have one resistor across ground, and that one resistor, if you measure the voltage, and what you're doing is when you measure a voltage, you're comparing it to something, and the microcontroller intrinsically compares analog voltages in against ground. So if you have one leg at ground and you have the other leg at the other side of a very small resistor, in this case 0.018 ohms, you get a very small voltage level that feeds into your microcontroller, in spite of the voltage level of the input being very high. This can be 3 to 44 volts in the V-Sense pin. So because of that, here, if we had 44 volts going through, we would just be comparing whatever the other side of a tiny resistor is to ground. So we get a very small voltage going into this microcontroller so we don't blow it up. The problem is that's what's called low side current detection. So you would have your load here, and then you would have your positive power there, and then this would go like that, and then this is already connected to ground, but you would connect this one to ground. And so all of that current would still be the amount of current flowing to your load. The problem is we can't isolate it like this. We actually can't isolate it like this. We don't have the ability to break the grounds free because, actually, wait, I want all those things again. Because inside of our load, we actually have a connection to ground. So this is invalid because this ground is going to be shared with all of the other voltages, all three of the other voltages. So we can't isolate out the one singular voltage that way because it just offers another path to ground. Now we can do this with negative 12 volts though. So we do have the ability to measure our negative voltage based on that. But again, we can't do it with we can't do it with the other ones. In this case, we would connect negative 12 to the low side, and then we would have this sitting at ground through the load. Or no, yeah, we would have this one sitting at ground. It's weird, but it would work. It would work. We get a negative voltage level. We just don't get a minus sign in front of it. So what I have to do is convert a low side current driver into a high side current driver. Well, lucky for us, this is just a voltage. This is just a positive voltage. And we can create a positive voltage with a low side current driver. In this case, I'm doing an over-the-top low side current driver. It's a little bit of a specialized part. It's a little bit expensive. But putting this circuit in there, this specific circuit, means that I get to pay about $7 a chip. I mean, it means that I get to put a lot of volts through our 3-volt circuit, and it won't blow it up over here. This is going to be 0 to 2.7 no matter what. The only difficulty that I'm having is tuning these two resistors. I wouldn't have to tune these two resistors if I could get into the microcontroller here and reprogram it. Now I would have to fully reprogram it. I'd have to fully reprogram this thing in order to run the current monitor. So that would mean testing a voltage or two on this and then finding a line of best fit equation and then tuning a couple currents and doing a line of best fit current equation and running that into numbers over time that would go on to the display. That's not a ton of work. That's not a ton of work, but I think that's too much because we already did all the testing of this circuit here. And if I can get those two resistors to be tuned properly, the two variable resistors to tune properly, then I would have a chance of actually getting this thing in tune. It's going to be an annoying process, but you know, I could figure it out. So that's explaining what we're up against. This is the final yak. We shave this yak, and we've got all of our hardware sorted out, and we can move on to software. That was sort of the advantage of this. So I was looking up displays, and I wasn't able to find anything. I really just could not find any information on the display. I mean, there's all kinds of 7-segment displays out there, but I need one that's 6 digits on 2 rows. 2-row, 7-segment display, 6-digit, and then it ignores me and it gives me a 1-row 7-segment display with 6 digits. 6-digit LED display. I can't even visit the website. I guess that's it. 6-digit 7-segment decimal. This is a 6-7-digit TM1637. The LED digital display module adopts the driver ICs connected to the I/O via 2 pins. See, the thing is, on our specific 7-segment display, we've reverse engineered the, hold on. We've reverse engineered this display board. It's very simple. It's just a 2-sided PCB, and because of the unique way that power and ground and the reset, the isolated reset pin on that silk screen there, the way that this stuff is configured, it appears as though this is an ATtiny 24. And it does match up with a lot of ATtiny 24 isms. The thing is, the display it's those 9 pins here, 9 pins on this side, and there's no part number on the display that we can perceive. It's only got 1 row of pins. All the other ones that I've been able to find have 2. I don't want to pull it out again. I'm just trying to show that I put this stuff to bed. See, there's an Arduino reference for it and everything. TM1637 datasheet. Yeah, it would be the second search here. Now. It's a kind of LED. What kind? Drive control circuit with keyboard scan interface. What? That's definitely not. Grid 1, grid 2, grid 3. Huh. LED drive control special circuit. So if it's using something like this, then this could do like everything. Where's my example circuit? Look at all that. And then it would just serial clock and DIO. I mean, it's possible they're using something like this inside of the chip. Although this is only 2 digits of digital. There would be enable and stuff. We just don't know. We just don't know. I mean, it's tough enough to find like yeah, see, that's 2 3-digit displays. And this thing is like all-in-one... Oh, wait, hold on. I was wrong. It's like an all-in-one 6-digit display. Oh, I didn't have anywhere to go on that one. We tried the old Google Images thing, and it didn't quite come up with... Like, this is the closest we got, and that one actually is 14 pins. It's not just 7. How did they get it to be so cheap is beyond me, too. I guess it must be just that specialized of a part. There's just, it's not, we've searched and searched and searched, and there's nothing. So if anybody has any ideas, I don't think I'm going to go down this road, though, because if we don't know what's going on, I would have to reverse engineer the protocol and come up with my own, and then get that onto the Arduino. And if it's using something that's unique that we can't really find, then I can't find a library. If I can't find a library, I can't code it up quickly and get it to run like you know, within a couple days. That's sort of the limitations on what we're doing. So line of best fit is probably my best plan here. Let me get some water, and then we'll get down to soldering. Oh, it's soda left over. All right. Okay, so modularity. I guess the way that we're going to do this is starting with a power supply. We have all of our inputs on one side, and then we go from one side to the other side, right? So in that case, I've got my 12-volt regulator, I've got my 5-volt regulator, and then I've got my minus 12-volt regulator. The 5-volt regulator is not going to be used all that often for the modular synthesizer stuff, but occasionally it will be used for... Basically, the 5 volts is going to be used primarily for the display, because the display uses 100 milliamps. But I need the metering connections on everything. So there's going to be a 4-pin connector for each of the displays. And since these things all route to ground anyway, I don't need that ground wire, and I don't need thick wires on these things because they shouldn't really be drawing that much current. I think this can go up to 1 amp. This can go to like 2, I think. This can do 5 at positive 12 volts. So anything that's 3 volts is going to be powered off of the 12 volt power. What I'll be doing is I'll be going 12 volts to 3 volts and powering all the displays off of one 1 amp driver. And then these will do their voltage sensing on all their individual voltages. Actually, wait, no, I'm not going to use 3 volts on this. These will be 5 volts because it needs to be above the, this needs to be above the supply current because it's got its own regulator. These have a 3-volt regulator inside of them. So I will be powering all of these off of 5 volts. 5 volts will, of course, be powered off of 12 volts. Minus 12. Actually, you know what? I think all of these will get the DC 15 volts. So we'll have negative 12, positive 12, and 5, all off of DC 15 volts coming in through the barrel plug. One of the debates that I had with myself is whether or not I wanted to have USB power. USB-C can provide us with 15 volts DC, at a couple of amps even. So if I include something like this board, this USB-C driver board, this thing has some type of a controller on it, and I'm not sure if that's an ASIC or not. It looks like it was sanded off. Some type of a controller on it that allows it to communicate with the power supply about getting 15 volts DC. So right now I have the jumper set to 001, which makes this a 15 volt DC supply. And so if I put this as one of the power inputs, I can then power it off of the big power brick that Amazon sent me by accident. And so it'll plug in just alongside of my oscilloscope and provide all the powers that this thing needs to create all of its supply voltages. And I guess I can do that using the cutoff here. But that means that if I turn off the machine, this thing will still be on power. But I guess is that okay? I guess it's okay. But then that would go somewhere around here, and it would really kind of squish all this power supply circuitry. I could move this stuff up a little bit just to give us a little room to breathe. I got to think about what the panel's going to look like too. Because, like, I guess that can push behind the 3D print a little bit. Yeah, I guess that works. If it's like that. But then we need the power switch. And now we don't have room for anything else. MIDI is going to have to go somewhere else. MIDI once again gets displaced somewhere else. Maybe above the rail. And then in addition to that, I also do want to have an external plug for programming the micro. So it would be a second, what up, 3D Printer Shack? A second panel mount USB is going to have to go on this panel over here. So I'm going to need like an additional panel up here. That, or depending on where I place my microcontroller, I guess I can plug directly into the micro if it's over on the end like that. Like if I put it here on this board goes on top of the other one. Because this is a full-sized board, I need to have the power supply connections up here. So there'll have to be a little like through connector for power. But then that goes here, and that gives me plenty of room to do all the digital stuff that I wanted to do. Like connector for the screen over here. Oh God, what else? I2C connector that'll go to wherever the buttons are. That are all the buttons come in over here and go to the port expander, which will have all kinds of other stuff connected to it. The buttons and the encoders, it'll be just a giant DuPont connector over here. I need to spread out on the circuit, though. I need to make sure that there's plenty of room for me to do what I need to do. Would this be on here? I don't know. I guess that works. And then on top of that is all of the outputs. And those will need to go to another board that has the muxes on them. Oh my God, there's so much to fit in the circuit. There's so much. It's crazy. So anyway, we need to start with the power supply. So I need everything power related to be down here, including our high side current drivers. So we'll have something like the -12, 5, +12, and I'll of course make labels for all of these. Use these buttons I recently got in, what's this? Hold on, I got my MS Paint is in the way of chat. Let me move that. I use these buttons I recently got in. Check them out. 8x12 AC black latching on off mini torch push button SMD. I don't need any of that. I've got the buttons that I need right here. I need to buy buttons. I'm drowning in them right now. I just bought a bunch of these that are additional millimeter long. Actually, those are right here. So I could replace all the buttons on this thing with ones that stick out a little bit. That'll happen at some point. All right, so I guess I am going to go with the additional USB-C input. So it can be either or of these two. This one, the USB-C, is the only one that I can find that has D+ and D- integrated into it, is from Adafruit. But the thing is, most of the USB-C stuff that I have around here doesn't use USB-C like super duper speeds. And so a bunch of just the little adapter cables to USB-C are all you really need. One that's able to actually have D+ and minus on it. But in order to provide ±15 volts at the correct current, I don't have any, except for the native back of the computer, back of the motherboard plugs that'll do that. I have one other plug that might be able to do that, but the ones that I have are all on power supplies. So it actually is kind of better that I have a dedicated ±15 volt unit coming in the back. That'll be its own separate plug. I guess I could do this one vertically too, but I don't think, no, that's not gonna fit because there's a rail like right here. So yeah, it'll have to be horizontal. So like most of the stuff, I'm not gonna have a data plug USB-C. That'll be somewhere else. And I might move the microcontroller and actually have a panel plug or 3D print little adapter for this guy, and then just have the USB-C be the interface, but it'll be on the back, and then it'll have a wire that goes over to where USB is. The possibilities are endless and my brain is exploding. Let's get header pins for this thing because I want this to be removable. That's what most of the stuff here is removable. I'm going to put this thing in, but then I may do some measurements and make like a 3D print that'll kind of grab onto it where I can use VKB on it. Or I could just do a stack of VKB going to this thing. The ones that are much better for this sort of application are the ones that have holes in the front where you can screw them to something and then you can kind of lock them down. You can either put them on headers for the circuit board or, you know, any of a number of things that would lock something like this down and stabilize it. Because USB-C has a mechanical click to it that is a little bit hard. And so you got to cater for that. I dropped all of these pins on the ground and they went everywhere and they mixed with dog hair. So there's a lot of dog hair in this bin right now. I need to do a big bin clean out. Get all the dog hair out of here. I guess there aren't that many 2 pins of the type that I'm using. The headers that I'm using are much more low profile than your typical thing, and I just need 2 pins out of them. So I guess this will do. Just take these 4. Big square pins can take up to an amp, but I don't know if these will be able to take up to an amp. Then again, on our 15 volts, well, no, 15 volts is supplying to everybody. We'll just see if it heats up. That's basically what we're doing. If it heats up, oops. It'll be more dramatic that way. So I need a heat sink, I need the soldering iron, and I need solder. And I'm running out of space because we've been working on this thing for a little while. Everything starts to get a little bit out of control, a little bit messy. But I'll use this thing, and then these go down here. This would actually be kind of useful for doing my own stuff. Oh, these need to plug in the other way around. I like them to lock in the plastic. So I do the big pad because they remove this way. Do this, do that. Let's get the distance right. So ground and VCC on a header pin in case I blow this thing up. That's kind of important. Just in case I blow it up. Things have happened around here. I'm scooching over so that we can get to the microscope. There we go. A little bit more central. When I'm programming, I'm pushed up against the side of the table, but I need to start moving back in this direction because things pile up and they start to crowd me out of my own workspace. Crowd me out. It's not fair. Yeah, so the design of this thing kind of annoys me. It's like they put this capacitor all the way up there. If I had anything, just even like an inkling of a hole through 2 areas here, I could potentially drill right in front of this cap. I could make a hole in this corner, and maybe that's what I should do. Not only that, but they're using... No, okay, I guess that goes in, because that would be very strong if it's soldered properly with a full via for the socket. That's important, because otherwise you plug this thing in and it'll pivot and it'll start to wear away at these pins down here. Is that a metal backing? It really shouldn't be. I think it's plastic backed. Yeah, I know you know all about it. We already had a conversation about these. This is the one that I was able to get quickly, but it doesn't have holes in the front. This doesn't stick out enough. What's up, Flatulent Godad? How you doing? This doesn't stick out enough for my liking because I need to have a 3D printed panel in front of this. I guess this would be okay for like a wooden panel, the distance between the front of the connector and this board. But for me, I'm going to have a 3D printed panel, so I need to have kind of a thin panel piece right around this. It'll be like 1 or 2 layers of stuff. And then we're soldering it down on pin headers so that if I blow it up, I can replace it. But this isn't going to be a very mechanically stable connection. I could do that. I could do a groove in the card. in the panel rather. It'll be on the bad bottom layer though. This is where I need 3 hands. I need to press down on the board and apply solder to one of the pins. I'll just do one first. I've done that before. I do that with your people's streams. All you guys out there, I find you. I was listening to one earlier today while just killing time a little bit. Just have background noise to me measuring and iterating through a design. It's nice to have. But then you get other streamers that come in and go, not really come in, they don't watch my stream. I'm not popular enough. But they go, I hate it. I hate when other streamers make a comment on my stream because it's like being in an office building and you hang out around the coffee maker after work hours. And I'm like, you've never worked in an office, you idiot. Like, you've never worked in an office. And that's not what this is like. Anyway. Use the big pins as screw holes. I don't like doing that, but that is an option, I suppose. I could drill holes in the PCB and then use a 3D print, because then that would isolate it. There's streamers like that. Yes, I've heard that exact word phrasing. It's one of these streamers that have come over from YouTube. Of course, I can't name names because that's against TOS, but it's one of these streamers that brought their audience over from YouTube and don't know the trials and tribulations of building your own Twitch audience. Whoever hangs out around the coffee machine after work hours. I know, but it's like, what if your coworkers were just that entertaining that you do stick around? And it's like, how do you get to know anyone who's streaming on Twitch if you don't watch streams? Right? Like, it's just one of those things. So it's like, no, I don't think it's rude at all. I don't think it's a weird thing at all. You can think it's weird, but I just disagree with that very strongly. I actually do like the idea of drilling through the board below it and putting some kind of a 3D printed dual standoff directly below. But no, I swears on me underwears. I have heard it. I have heard it communicated like that. This is still kind of crooked, huh? Yeah, I can fix that by heating it up a little bit. Hold on a sec. It's just a little bit crooked, and that's going to make all my numbers weird. They're just being precious. That's a great way of describing it. It's nobody you guys know. Honestly, didn't say that you should use the holes as screw holes, just mounting holes. Well, I'm thinking about using them as screw holes because the screws I have aren't very conductive. These are far enough apart that if I put 2 cap heads on it, they won't touch each other. And that gives me 2 big screw holes at the back of this board. Obviously, the board is then still this big cantilever, but if I have a big piece of plastic under this, it will stabilize it pretty well. So if this is the next component that's going in, let me move all this stuff. Because I've got to flip the board over to do this, and it's just going to fall out. Add a groove in the back panel. I don't want to add a groove in the back of the panel. The panel's going to be... Well, how thick are we going to be, actually? I got this, man. I know what I'm doing. We'll design the back panel in a little bit, but I have an idea of how I'm going to do this. It's just going to be a big plastic insert that screws in on the back here, and that'll just support everything. I'll just have this big piece of plastic there, and maybe I could put other holes in the plastic in order to screw in other parts of this, but I think generally if I just put a big piece of plastic on the back here and have 2 screws in it, although it is a giant cantilever, if I've got the oval around this thing, that'll support it going up and down. And that'll kind of hold things in. I'll have to make the piece of plastic before I drill the hole, though, because if I try to drill it like this, my drill bit's going to go all over the place. And if I have the plastic around the drill bit, that'll keep it from going into the side holes. But like, I gotta figure out where the panel's gonna be. That would be the gonad solution, is the lump of blue tack. I'm not as gung-ho about my blue tack as he is. Plus, I don't have any. I don't have any in the shop. I don't use it. In America, we use American cheese. And we like it. That's how we've always had it. I love how the Kraft Deluxe macaroni and cheese, Canadians will all have their own little recipes for how they prepare it. They have their own little recipe about how they do Kraft dinner. They call it Kraft dinner, but it's the Deluxe Kraft macaroni and cheese. Sealing holes in submarines. Who have you been talking to? American cheese is good for what it is. It is meat lubricant. It is designed to get meat into your body in a more efficient manner. You could use a ledge on the cover to come out and screw into support the whole board. I could do what I was thinking of is have a screw from below and then have screws on the sides here and have the screw go in and just pinch the sides of the board, and that would keep it mechanically stable as well. Liquid electrical tape. No, it's not yellow plastic. It is cheese. It's just the specific definition of cheese as per what can be claimed as cheese has a certain oil content in it or something like it. It has something to do with the way that actually the cheese is reconstituted back into itself. All the excess goes back into the rest of it. But American cheese is very good at what it does. I put it on ramen today because that's against my better judgment. Against my better judgment, I put American cheese on ramen because it was already cheese-flavored ramen. And it was actually fine. It was very good. Made kind of a very spicy mac and cheese out of the whole thing. It's not crude oil. Come on. All these, by the way, all the people criticizing are not Americans. So if I'm going to have the power switch over here, that's going to go into the device a little bit. And then I won't have room for the MIDI plug on this face. Now, if I had a little bit more room with the plug not being, I mean, that fits too, but barely. But then I definitely can't put the MIDI connector on the side. So it's this and then the MIDI. And there's not a whole lot of room for this board to slide. It's kind of locked in its position. So if I didn't do the USB power plug, if I left that out, then I could do the MIDI and the power switch. And this stuff doesn't stick there, it just falls out, so. Can't really fit this anywhere else unless it's on a different board and it goes to like a different row, like up here. The reason that I want MIDI to be down on this row is because this one's supported on all 4 sides, whereas this one isn't. It has 3 sides unless I put another bar in there, and I don't think I have a bar that's really going to fit quite well. Well, no, up here there will be a USB plug. I will put a USB plug up there, but the power plug, the one that negotiates plus minus 15 volts, and I can use with my oscilloscope power supply. So I can plug this thing in as well as my O-scope to that power supply back there, and then I don't have to have a power brick that's dedicated to this thing. And then the barrel plug has a cutoff for when you plug in another power supply, so I can have this cut off. Stacked above it on the lower level. You mean, wait, what are you saying? You're saying This has a flange on it though, because it's a panel mount. Unless I use a different power button, unless I find like a power switch. I don't really want a big toggle switch on it. I'd rather have the more professional panel mount power plug. Because this thing is easy to intuit when you're trying to turn something off that's exploding. But there are alternatives. Man, that fucking thing to say. Okay, let's get my other switches in here. Where are they? Those are toggles. Those aren't what I want. I have a bin that's full of power style switches. Not as many as I thought. Those are on, off, on. Hold on. Still looking. Still looking. Not that one. What is this one? I'm getting examples. Just hold on. What are you? You're chips and stuff. You have no switches. No switches. Switches get stitches. This one. Yeah, here's some up here. USB board over the barrel plug. You might be onto something. Let's take a look in just a second. Yeah, there might be space. The problem is the circuit board is kind of high up. I don't know if I want to change that, but I could. I could just have a flat bar and the circuit board's like right up against it. Different style power buttons. Giant toggle. I don't like that. This thing. Nah. Nah. I don't know. These are kind of dumb. This one could work. That's the same action as the other one. It doesn't have the big I/O printed on it, though. And it's a little bit more recessed where I can fit it. Although it would mesh a little bit better with the rest of everything else. Hey, Kervos. No, vertical doesn't work because it's too tall. It's too tall for what I have left. For what I have left of this. Woe is me. Let's get a better shot of it so you guys get the same information that I do. I need to put the microscope button on this this panel. Here, I'm gonna try to rearrange things a little bit so that we can, because we're only doing the modules today. We're not doing testing. I'm trying to get a layout started, and then I can start wiring everything up. Because I think we're ready. We're ready to have the fully realized hardware on this. And once I have fully realized hardware, then I have the ability to get into the software and really explain what's going on. And actually like get modules of the software working. You might be onto something. I think you're onto something, Jacose. Maybe I could have put that a little bit more central too. I think you're onto something with the vertical thing. The only problem I'm going to have with that is there's not a lot of room for me to have something that supports the board. But if there's a tight-fitting oval around this, then it will be supported in the XY, and then in the Z, the pressing it in, I can have a singular screw on the back end. So like the XY will be up here, and then in terms of pushing it in, that will be the screw on the back end, and I think that'll stabilize it enough. You know, as long as its output is tightly fit, not super tight. I mean, there can be a little bit of wiggle room, but as long as it doesn't have too much wiggle room to like break anything, then I think that'll be okay. I'll just have like a big block of plastic on the back end with a screw going in each direction. Yeah. Exactly. I don't need both screws. I could just do one from each side on a plastic block with 2 holes in it. That's perfect. Although with the XY, I could have some. No, I don't need that. I don't need that. I need to overcomplicate it. It can just be a block of plastic. You know, all the acts that we're shaving can be very much overcomplicated. So I'm going to need to find standoffs that'll push this up a little bit more than it already is. so that it can solder in, you know, like this with just a little bit of space in there. And I don't think I need to use this rocker. This thing is very compact. It's a cool little piece, but I don't think it sticks out from the board far enough, because the 3D print is going to come to the edge on all 4 of these sides, and we'll need a little clearance for the plug on this one. It'll come to the edge on all 4 sides. There will be just enough room for a plug in there. Too bad I can't have it like vertically. And I don't know if I can move this. I could move this over. I don't want to desolder it right now. I don't want to desolder that. Yeah, maybe a hole in a pin. That's a good idea. And then the interface to the circuit board below will be just 1 screw. Well, maybe, I don't know. I'm not sure how I could do that. I think this is a little too compact. But then this gets removed with the PCB. So if I have to disassemble it, this whole thing comes with it. I need to make 3 holes there. That would be kind of awkward, though. Room for a powered LED behind the socket. I could put that like here. Although the plug would block it, but whatever. I could put a 15-volt monitor LED here and have that stick out. And then this would be MIDI all the way up front. Or maybe MIDI here, and then the power plug. And this will have 2 leads coming off of it so that we can pretty much put it anywhere, but it just has to kind of fit in this area. And that's going to be back a little bit with MIDI. So this whole area is a no man's land. And then I need a socket over here that's going to be the power leads. And that'll be a 2-pin JST. I don't know how much current this thing is going to draw, but I think just JST with a normal sized wire will be enough for it. All right, why is my face cam on? I really don't need you guys to see me scratching my eyes all the time. The allergens are nuts today. It's crazy time. All right, so if that's going to be the back panel, we need to figure out where stuff's going to go. Three ESPs and a USB hub. That sounds like a sitcom. 140mm fin. Jeez. You're doing some weird stuff. Yeah, I would love to give this thing its own dedicated, like, 115-volt AC power plug, but this is all low current electronics, so it's safer to have something like a brick on it. I mean, those ESPs are pretty compact as it is. You shouldn't be having too much trouble, right? Okay, so we need a back panel. Now, this is something that can print up in not all that much time. I have a poly fuse that I stole from this board that I never use. I have this Yo-Yo IOIO board, and it had this really tiny poly fuse on it. And I don't know if it might be too small. It might be too small of a poly fuse. I don't use this. This is bound for the trash. So I stole one from this. I need to find a larger one. And I thought I had them, and I looked through my whole collection of surface mount, but I just don't know. But it's going to be 15 volts in, either from USB-C or from the barrel plug. And I figure I take whatever voltage is here, and I use the barrel plug's internal switch in order to switch it out. I think that's how this one works. Let's just do a multimeter on this one real quick. I'll do a multimeter on the barrel plug and just figure out how that internal switch works. It might work with ground, in which case I would be cutting this thing off from ground. I don't think that works. Okay, hold on. Let me grab a barrel plug. I know I had one sitting over here. Here it is. It's the one that came with these sockets. You know, I could have had everything be panel mount in that area. That's probably the better way to do it. Probably the better way to be doing that, but yeah, okay. So barrel plug, barrel socket, 3 pins, 1 pin. Get out of here, wires. Maybe I should just unplug these. Eh, eh, eh. We got the screen working, and we barely got a hello world pumping out of it. So I figured that's enough of the screen. We know that it works, so we can hook all of the hardware up together now. And I can, one bit at a time, get everything running. Yeah, I don't really trust those PCB mounted ones. Plus, in addition to this, I want to keep a little bit of room in the area because I might want to do the 3-pin audio jack MIDI, which varies from producer to producer. Whoever's making these MIDI jacks, they can't really figure out which way to do it. But if I want to, I could have that 3-pin plug with just like a panel mount 3-pin socket and then wire that up myself on the back of this thing. I can add it at a later date. I don't want to bite off too much at this point. I've already bitten off more than I can chew. We're trying to shove it down with a big glass of water, but I don't want to add more at this point. Add more cinnamon to this challenge. Okay, so from the ground socket here, I get nothing. Good day to you, sir. And if I unplug this and I go to the ground here, I get a connection. So these two pins, the one that I can get to here and this one on the side. Oh, wait a minute. So that's OL, LOL. But if I plug something in, it's still OL. So is that cutting off the power pin? If I go from this pin to this pin, nothing. But if I unplug and I go from this pin to this pin, all right, who's messing with me? Probably fine if it goes straight into the PCB, but the 90-degree ones I've seen just, yeah, seem shady. It's good if you have screws on those. You want a screw that goes into the panel. That's the best way to do it, because then you have a couple screws that you release on the panel and you can get the PCB out instead of having to fully disassemble everything. Unfortunately, I can't do that, so I'm going to have the two panel mount plugs that'll need to be unplugged somewhere on the PCB, and then the PCB can come out. Such is life. Oh, I see. That's not connected to that. Wait. Oh, I see. I was on the wrong pin. So this one here is probably connected to this one here now. Yes, indeed. Okay. So those two are connected, and those are the grounds. And then if you plug this thing in, yeah, that's what it's going to be. It's going to be a lot of little JST connectors, and I'm going to have to label everything very clearly. This is a systems kind of design. So see how they're cut off now? So this is a systems sort of design. So each block, like each area block, is going to have a different system in it that's going to have a bunch of PCBs on standoffs or small circuits in each location. And spreading it out and keeping it very logical and systematic allows you to troubleshoot things like this much easier. Using JST connectors means that I can use normal jumpers to get to all the pins that I need to, or I could even make a custom JST connector to get to things. JST is just nice and easy. This makes it, these are basically the size of pin headers and the same spacing as pin headers, but they've got keyways on them so that it helps you not blow up your design by plugging things in upside down. So this is a ground cutoff. What does that mean for us? This thing does not have a shutdown pin as far as I know. Usually these things will have like a ground pin that you would connect in order to shut it off. If I isolate this thing from the rest of the board, if I disconnect the ground and I plug my USB in as well as a barrel plug, does something explode? Do I blow something up? Not going to get a lot of information from the microcontroller. I don't think that's an AT-Tiny or anything. It might be an ASIC, but they're keeping it secret as to what the ASIC is. There's a 78L05 on this thing? What the heck, guys? Come on. Get a little bit more inspired. Use something that's a little bit less super boring and common. If it's so close to the barrel plug that it blocks it, maybe. A USB plug is not going to block the barrel plug, though. If it was directly up, like right up against the side of it, that would actually work just fine. But I don't think I can manage that with this PCB. Yeah, because that is a very clever, that's a very gonad way to do it. That's a very clever way to do it, is to have it so close that when you plug, hold on, I got a plug over here. Just grab an example that doesn't have power on it. Well, actually, we can test to see if this thing works. See, there's the LED on. And then if I test voltage on this thing, I had the multimeter out. Let me get it again. See, this would be really cool to be able to plug in and use on my in my bench setup. .05 volts. So that's great. Pretty cool. But like, would it be safe to use the barrel cutoff or have it, well, it's not going to be I'm not going to be able to really get it close enough for it to be like a physical cut. Let me get a different plug so that I'm not powering this thing up while we're moving it around, because it'll short against stuff. This goes directly to my expensive power supply. And again, that's why it's so cool to be able to use the USB, is that I could just plug this thing in and it would be powered. And then I could test the module. And then this cable can retract back over there. This one is a Nintendo plug. I don't know if I really want to use the Nintendo power cable. Was there a USB-C power cable like sitting around here? That one's USB micro. I thought I had one. I think I threw it across the shop because I didn't need for it to be over here. I had one, but I threw it away. I threw it all away. What a waste. All right, I'll just unplug the Anchor one. The Anchor one's a little bit compact, but we can just use it as our unpowered cable. You replace the power cable in the SNES with the USB-C. That's pretty cool. Yeah, so plugging this thing in like this, it really is very close to the size of the hole that it would feature. So like this, I still have plenty of room to get that in there. The only way it would be blocking is if one of these are a bit bigger than the other. Unfortunately, both of these are about their own footprints. They're about the size of their own footprints, which is a shame. Let's see, I can't do this because then I can't fit this, and then this is crowded out. That vertically doesn't really work. It's actually out here. Yeah, because those will not fit with each other. It's like everybody's crowding in. If I move this down, I could barely fit everybody horizontally. No, it's that they fit in their own footprints. Like, there's so much room around the plug here that even if I put this right up against it, I mean, if they are right up against one another, there's a chance that they could crowd each other out. But even then, this will plug in sideways. I'm not inverting the board. I guess that would do it, though. If that were right up against it, like this, then you could plug this in, but not this. And you would have to unplug one to get the other, and that's clever. A 3D printed window that slides back and forth. That would be another way to do it. Okay, that's fine, but I don't know. You guys are very, very clever, but I don't know if I can do that. If I put power in and it goes up to this PCB, hold on, let me clear off this PCB so I can get into the position. So this one goes here, and then this would go up instead of down, which would really confuse a lot of the connections. I don't know where this is going. Hold on. Maybe like that. Go one further forward. It doesn't really line up too well, but it does kind of... Nah, it doesn't quite fit. A little too close. Yeah, if I'm the one using it, no, I don't plan on plugging them both in at the same time. I could also put a rocker switch on it. That actually is probably the way to go. That would just cut off power from one or the other. So if I put them anywhere, so they could be next to each other like this, but then I can use this space here to put a rocker switch and just have a selection of which power you're using. Maybe that's the way to do it. That's probably the simplest thing. KSS, chat. KSS. Where's my thing with the... Okay, they're there. Do I have a normal-sized rocker switch? I have all these giant ones in this bin. I have another location with different switches. This one's nice and long. It also has huge terminals that I don't need. It's also missing a couple. What the heck? Weird. It's way too big. It's huge. It's way too huge. Just put it like that. No. One of these things, the 120, 115, 230s? I don't think so. The problem with the theory that if I'm the only one using it, then I can just not plug them both in is that I don't think you understand how dumb I am. I don't think you have quite a grasp over how dumb I am. Yeah, 15 volts is being routed to a 12 volt and a 5 volt and a minus 12 volt. My bro switched that on the back of his PC many years ago. It went off like a firework. I love how they just decided that the Brits, they were totally fine with the Brits blowing everything up, and the Americans were the ones who, if they mess up the switch, things just don't turn on. While it was running, holy shit. Yeah, they just decided that all the international power standard people should be smarter about their appliances. See, what's supposed to happen in here is that ground cutoff is supposed to be able to isolate the power supply. Yeah, I could just put a diode or... I could do that. It's unfortunate that I can't disable either, though, fully. The smell. Keep looking at all these O-ring power supplies. I keep searching for O-rings on the internet to try to put these two power supplies together, and I just get the worst stuff. What's up, Pyro? Like that. Oh god, he's pulling FETs into the equation. If you're using a typical DC jack with 3 pins, I'm not sure anything extra is required, as without the jack inserted, one of the pins is connected to the center pin. With the jack inserted, this disconnects. So you can use this pin to supply the USB power with no jack. But the problem is, okay, so what I'm seeing here in the power supply design, let's go over to the power supply area. If I've got a barrel plug, what it's basically going to be is a pin, and then it's got this ground cutoff on the pin. So that when I insert the barrel, it's going to cut off the second pin, and And then of course we've got the third pin, which is the barrel. Let me look up the schematic symbol. I don't have to make this up as I go along. Somebody's made a more logical barrel jack schematic images. Oh, okay, so they got this kind of setup. So they've got a huge barrel. Okay, so barrel jack here. So let's do a box. A little smaller. And then we have like a dildo. Let me get in a little closer. Candle jack? No. Then we have one of these. One of these. And we have dirt. So this one cuts off when it's connected. So what I could have is down here, I would have the USB board. And then we would do plus minus. Oh, that's too thick. And so what would it be? It would then be, actually that should be above. Well, or I do it the other way. Well, I don't know. Okay, oh, hold on. So this is all based on grounds, because this is plus and then this is minus. So what happens is this one remains connected to minus and this one gets cut off. So what we have is we have this one natively just go to negative. And then this one goes up to this one's negative and feeds it to that. But that means that these two are connected internally to our, oh wait. To plus 15. So what then happens if I plug in another USB socket? If I have a different USB, that already has a ground, and I plug something into this from my, like it wouldn't be the same source, I guess, as this one. So that one wouldn't be double connected, would it? This would always be cut off from USB-C. If I plug in USB-C here to the computer, is that going to create some kind of like a path where some nightmare current can get through? I don't think so. But when you OR power supplies with diodes, you put diodes in the path, and then you can't get like a feedback. But are these two going to combine their powers, or is one going to cause the other one to run away and do a weird thing? Because that can sometimes happen too. One can influence the other one and get it to do all kinds of weird shit. It's like every single power input would need a diode on it. But if I plug this in, then this floats. So this is supplying between plus and float. And there's no way for that current to get back to that board. Unless there's some kind of a crosstalk between the two. I wouldn't be plugging two USB power supplies into this thing, that's for sure. Is that safe? I mean, it's safe in like the 1980s when you would have like a charging circuit or something. And so if this throughput is connected, then it wouldn't try to charge the batteries with your own battery power. I hate how that doesn't cut off positive. And I guess maybe that's where like a FET comes into play. Barrel jack PSU isolation. Oh my god, so many weird things. Yeah, so you would do something like cut off a battery when you plug in the barrel jack. And then there they've got diodes in order to do flow control prevention. So, I mean, the way that I guess if I just put diodes in the path. So that would look like yeah, the direction. So it'd be like that, and then this. Yeah, not sure about 2 floating power supplies. Well, in this case, this would prevent current from going back through whatever circuitry this is providing. So I guess that's the way to go. I guess we got to do it that way. And then, of course, I need some big capacitors over here. Just because. Just to be nice. I mean, a little 3D printed window would be kind of funny, but the window would eventually fall out. So have like a little up and down flap. And then alternatively, the other way to do it is to find a little switch that can just go over here, and I can just flick it between the two. Yeah, floating grounds are not very good in circuits like this because with everything in this device has ground connections, and ground is ubiquitous because that's a great way to prevent from like static electricity and stuff like that. So you have these big ground paths that lead you down and out of your device. The only problem with that is that if you're doing floating grounds, you've got all of these areas that there can be an ingress in current suddenly. And so if something connects wrong, suddenly you can have like 30 volts on your line or, you know, something weird like that. Yeah, I think you're, aside from the suggestion where I put them like this, right next to each other, or if I could somehow have this vertical and butted right up against the side, or if these were both panel mounted and I put them right up against one another so that they don't plug in at the same time, that would be great. But it's a little too complicated for what I've got on hand right now. And remember, we're using whatever I have on hand. I'm not reinventing the wheel here. Having this inset just a little bit and having slightly thin material right next to it, that works out fine. I can actually be right up against it like that too. I mean, it's mostly about what's easier for me to put together right now. And I want to have this to be unpluggable in case it breaks and I need to make another one, which kind of offsets it a little bit. It's not quite centered on that, which I don't like, but that's just going to have to be the way it lives. Or I put it above and that frees up space for other stuff. My voice is not liking streaming today. I mean, I can't put them right up against each other, but I could also put a switch over here where I can flip between the two. And that way I can cut off positives using the switch. There are many complicated ways to do power supply stuff, but I think this is okay. Multi-layer sandwich does make it tricky to fix. Only if there was the PCB up here. If it's like this, that's not too bad. There's only one thing on top of each other. Okay, that said, what am I looking for? Do I need a toggle switch for them, or should I do it a different way? Do I have a toggle switch for them? I had toggle switches stashed somewhere. Smaller toggle switches. I don't know what happened to them. There were some micro toggle switches, but I don't think we're ready for that. I don't think that's quite what's required here. None of these are toggles. I moved them off. Let's see. Toggle switches. Got a whole bin full of stuff. This is all the modular stuff, but these use actually slider switches is what I'm looking for. Also, I do have alternative barrel plugs, but I don't think I have any in that size that are panel only. I have smaller ones. These are all smaller. And then these are all this kind, toggles, on, off, on. Selectors, don't need those. That's not good for this application. How do I not have rocker switches in this size? I don't understand. Maybe I've used them in too many projects and they dwindled my supply. That or I include both and just under recommendation, never plug in both at the same time. One day though, one day that will happen. And I will plug in both at the same time, but maybe we just risk it. We just risk it for the biscuit and just continue on with what we're doing. Do you really trust me to have only one 15-volt cable and one USB-C? Because that certainly is not going to be the case. On-off could be power for 2 sockets with one in the middle. That if I have that kind of switch, do I have that kind of switch? Let me see. I don't want to use the lever ones, but I may have an on-off-on rocker. I want that rocker switch because it's a familiar feel, and if something is in the midst of explosion, like if it's in the middle of actually detonating, I will know to reach to the right area and flip it very quickly. I'm kind of playing on that familiarity. Hold on, I'm looking through bins. I got all kinds of stuff in bins. Oh, and actually I could put a larger polyfuse on this. These are the bigger polyfuses. Although these are like multi-amp polyfuses, and I've never ever been able to set one off. Could try plugging both in under controlled, whatever it's called. O-ring. Controlled O-ring scenario. I could try one of these, the smallest polyfuse that I have. Maybe that would protect the rest of them. That's a capacitor. Wait a minute. It's not a polyfuse at all. That's a polyfuse. Use burn the subs to burn a warning label. I can 3D print text on this thing, you know. I'll have you know, sir, or madame, that I'm in control. I'm fully in control. If I do like a MOSFET circuit where you click it to one side, pieces of plastic to all of the cables in the shop. You guys love to escalate, huh? Wait, this it's a converted, it's a slider switch. This is a slider switch with a rocker conversion on top of it. What the shit? Huh? Well, if I had an on-off-on slider, I don't think I do. An elaborate combination of 3 switches could give you the ability to... Weird. That's a very weird one. Let's see. These, I think, are not... Yeah, those are just one or the other. So is that's just a button. These are just elaborate buttons. I don't have an on-off-on rocker. What they're suggesting is that if I have a 3-position rocker switch, I could use it like those 3-position toggles, and I could have the middle position be off. One would be the barrel plug, and then the other one would be the USB-C. And that way I could cut off the positive lead of both of them. Or both leads, depending on what kind of switch it is. Here's your classic on-off switch. Everybody has to have a couple of these. They just have the feel. It's pop, pop. Good feel. All right, so I don't have the right kind of switch to do that. Need boxes like this for my prep room at work. It's good to be able to see inside of the boxes. The other type of box that I use is a sewing kit box from Michaels, and that holds a bunch of parts in it, and you can just see what you're looking at, you know, when you grab the box. Yeah, I could do like a patch panel of banana plugs that I could configure the power supply with. This is about to fall, isn't it? All this stuff right here is about to fall over. Yep, there it goes. Jeez. back there. There's probably like a specialty switch in one of these bins somewhere that I put aside that's got just the right stuff. There's a mercury switch in this one. Maybe if I use a mercury switch and I tilt it just right. Nah, bah humbug. I thought that I had just the right thing, but turns out O-ring power supply is a little bit more challenging than I thought it would be. If I had just a reasonably sized toggle switch that could take that current, it would be fine. But that's getting more and more rare, or sorry, slider switch. That's getting more and more rare on electronics, the slider switches. I could do some kind of a transistor circuit that would detect whichever one's coming in. I could do, I mean, these things are 30 volt compatible, most of the power supplies. If we plug in the two power supplies in parallel, if I have those diodes there, then this design should be fine, because that'll cut off. This will be isolated. There's no case ground on this thing. But then if I plug in a USB here, is this going to have some kind of a path through there that's going to curse everything and create weird voltage potentials? I'm not sure that would be the case. What are the USB-C things that I'm looking at over here? I mean, yeah, like this, I could use this toggle. I could also add a toggle to toggle between the two power supplies. So I could add just a one side or the other for the input. Yeah, I've seen relays. I actually don't know if I've ever seen a relay being used like that, but I don't want a toggle sticking out of this thing. And I think it's more professional not to have somebody choose which power supply to use. One of the big industrial ones, because the industrial contactor, like motor contactor, so it goes chunk, makes a real big clunk noise with all that magnetic energy. I think those need 220 volts. I have Schottky diodes. Are they going to stand up to 15 volts? What are the Schottky diodes that I have? Let's take a look. Hold on. Surface mount diodes here. Power supplies are a trip, huh? They're always a little bit tough to design for. 1N5819. One N5819. Let's look those up. I have a whole box of old monitor contactors. Motor contactors, sorry. The lowest coil voltage I have is 24 volts. Yeah. Those are great, though. Where are we? Okay, 1N5819. We're taking our time on this because I want to get this right. IF is 1 amp. Reverse is 20, 30, and 40 voltage. IFSM is 25. Oh, is it 25 forward and 1 amp backwards? Or 1 amp forwards and 25? What is FSM versus F parentheses AV? Maximum repetitive peak reverse voltage, 20, 30, 40. 5819. So we're 10 volts above the combination of the two. Yeah, FSM is Flying Spaghetti Monster. Bless his noodly appendage. But what is maximum DC blocking voltage? 40 volts on the 5819. Non-repetitive peak reverse voltage. Non-repetitive 48. We're not going to get anywhere near that. Average forward rectified current 1 amp. That's pushing it a little bit. 1 amp at 15 volts versus what the PSU can provide, which shouldn't be close to that. It might be 2 amps max, versus what the module is going to use. It's going to use a couple hundred milliamps. It's not a lightweight power thing. It's going to use a couple hundred. It probably shouldn't get near an amp. And our current monitors will be able to display more than that. I mean, maybe these work. They might be a little bit tight on the specs. And then instead of 15, we're going to get 14.9 volts through these things. I guess we're doing O-ring diodes. O-ring, like unionizing, right? O-ring and unionizing. O-ring versus unionizing. We are unionizing these power supplies with an O-ring. Written down, that sentence would be impossible to parse. Unionizing, yeah, that too. I'm being unionized. I actually feel like I've been onionized. Every single meal I've had in the past, like, 2 years has had onion in it. The trick with onions, if you're cooking with onions, if they say to get the onions soft before putting them in your recipe, and the recipe touts itself as like a half-hour recipe, they're wrong. It's actually like a 50-minute to an hour and 10-minute recipe, because those onions, you want to be, if you're frying your onions as one of your steps in your recipe, do yourself a favor, give it a try of frying the onions for 20 minutes. 20 minutes. 20 minutes on low heat with your onions, and that will properly bring out all of those beautiful carbohydrates. Your onions will become very sweet fried onions. It's a really flavorful thing to do to a recipe. If you're going to be adding onions just for umami, like if you're making like I don't know, if you're making a like mushroom and onion combination, right? Throw those onions in, give them a full like 20 minutes to fry. Then throw your onions in and get everybody happy together and make sure they're happy. But if you do that, everybody's going to be like, oh my God, this is the best thing I've ever tasted. And you're like, all I did was put onions in a pan. That's the trick. All these recipes are trying to save time. They tell you can make dinner in 10 minutes, and it's something that requires fried onions. You best believe that they're cutting you short on that flavor. Baking powder to speed up the process. Interesting. How close does that get? I would really like to put these next to each other because that's much easier for me to design. Yeah, you can't cut corners with onions. You can cut onions. Somebody's cutting onions in here. But yeah. They're absolutely delicious if you do them properly. Don't be fooled by the whole, like, recipe-osphere on the internet. My father was a mean drunk. Anyway, here's my recipe for Rice Krispie treats. All of them trying to explain their entire life story. If I do it this way and I put the O-ring diodes on them, then I have a chance that this will turn out okay. And then this plugging in just like that. And then there's almost no room, almost not room for the other thing. Although they do technically fit together. Yeah, they fit together like that too easily. It's a shame I can't do that. I have regrets now. Like this with a switch right here would be great. I don't know if I can manage that. This is going to be tough to do anyway, so I think I might as well just relegate myself to putting these like this. This thing upside down would actually make it fit a little bit more evenly, so maybe I do need to flip this over and do it like this. Yeah, actually, I'm going to desolder this. I'm going to take these legs off and then flip it upside down. Which is annoying because all the good stuff on the circuit board's here. Unless I permanently attach it. If I just do pin headers straight through this thing, then this thing can fit closer to the board. If I do want it unpluggable, putting it above would be better. There are so many choices on this thing that it's driving me crazy. So many stupid little choices. I would like to have this thing centered on this. I wish it had the 2 screw holes, because then I could make it panel mount. But if I get rid of one of the layers, the low profile thing, these are even lower profile, and then I solder it in permanently at that height. I don't have the kind of pins that like go into the through-hole stuff and make a little like low-profile socket. So if this solders in, it would be one of the only daughter boards that solders in permanently. That goes there. This is our, by the way, this is our first step, the power ingress to the rest of the circuit. So if I get this right, the rest of the circuit will follow in kind. It's worth kind of sweating the small stuff at this point. Oops, well that unplugged. I could put it in 3 sockets and then it would be tall enough. I could also tape this to the circuit board with VKB tape, and then it would be super secure. Maybe that's the way we do it. The tape gives it a little bit of wiggle room, but that tape is so strong that it'll hopefully keep it super attached. And then it just becomes a permanent feature on the board, and I'd have to desolder it to get rid of it. But with a VKB tape there, it kind of becomes a permanent resident anyway. That means I don't need to 3D print anything. My coffee tastes like maple syrup. I did not add to any of it. Is it an old cup? This isn't coming off. You're not one of those people that doesn't wash their coffee cups. People in the office, I've seen the grossest coffee cup you've ever seen. And I go, why would you do this to yourself? You're smarter than this. And they go, it adds flavor. And I go, I'm not ever going to get within like talking distance of you ever again. You're dead to me. You are dead to me. You're dead to me. Were they in the military? Yes, actually. Yeah, there were a lot of military people in that office. Botulism equals flavor. It was just nasty coffee stains that had layered up over the course of many years. Way too many years. Like, bro, it's simple. Take it home, put it in the washing machine, or run some water over it occasionally. You don't have to do this to yourself. It's not a cast iron skillet, it's a coffee mug that says, I hate Mondays, with a picture of Garfield and leaded paint. No, it was actually just a normal unlabeled coffee mug. The patina, ugh. Ugh. That's not how that works. Not how patina works. I have a choice of how to directly mount this to the board. I could put a piece of like double-sided tape on it and do it down like this, but that's kind of putting it way too low. See how it's not centered with that thing? So I'm going to put maybe 2 pieces of VKB tape underneath it and then use pin headers. So the VKB tape is a particular brand of 3M double-sided tape. If I can find it, where did I put it? I haven't used it in a little while, so it is found a new location. Never follow VKB tape to a second location. Let's see here if I can find it. Get this cup out of the way. Have a cup of tea, have another one. That's one of those weird British songs that Gonad dug out of a grave from like the 60s or something, and it is now a permanent resident in my head. Have a cup of tea, have another one. It's just like, oh my God. So this is VKB tape. They use this on all kinds of things, including car external accessories and stuff like that. Yeah, every time I'm feeling like a little manic or overcaffeinated, I'm like, have a cup of tea, have another one. But I have used this in many, many horrible ways to attach things semi-permanently to one another. It can come up clean, it just doesn't like to come up at all. If something gets enough time squished, this stuff just holds it almost permanently. So what I can do is I can get the board mounted onto this thing, VHB, yeah, sorry, I get that wrong. VKB is a brand of accessory. It's a Russian brand of simulator stuff. Oh, that's the song. There it is. So this is VHP. I always get that wrong. VHP, VKB, VHP tape. Very, very good stuff. It's worth having in electronics if you're putting together especially stuff that consists of a lot of different modules. Because if you want something to not move and it's only connected to from board to board with wires, this thing will hold it in there permanently. Now, technically, you shouldn't just be connecting things with wires, because if you have modules like this, you want to take advantage of the fact that they're modular and have sockets. So I have these low profile sockets that hold on like you wouldn't believe. You need kind of like a screwdriver in order to get these things separate. You have to kind of like really pry them to get them apart. But that means that these things are modular, and if this ever explodes because I accidentally connect 120 volts to my inputs, then I can go to Amazon and buy another one and just bloop, pop it right back in. Yeah, door moldings on cars for decades, exactly. This stuff like sometimes does not want to negotiate, but you can get it off clean if you're careful. You just have to be real careful. So 2 layers of that with this will still be a little bit pliable. This will still be able to move just a little bit, which is probably bad for the long term, but or use alcohol. This isn't like what do you call it? Hot glue. I don't think alcohol pops this stuff off. If it does, I'm shocked, and I've been shocked before about that. Alcohol for yourself. I've tried to get at like the number panels that have been taped on with a tool that was a little bit too hard for the car's paint, and I accidentally scratched all up the area trying to debadge my VW. If you prep the surface with sandpaper and adhesion promoter the bond is insane. I prep my surface for VHP tape with finger oil to try to make it a little bit weaker. I don't care that I'm getting my finger oil all over that, because this will still stick way too much. So, okay, let's get a square header on this. Since this is power ingress, having 2 square headers would be nice, because that means that we get a little bit more current from this thing without heating up our traces, or wires in this case. So I need pin headers. Pin headers! And I need to check the height, too. That. Pin headers. Maybe, perhaps we could find. Let's see. Square headers that are not at a right angle. All the stuff that we've considered today, this is just such a... There's so many decisions to be made. I could try to find my slightly shorter versions of these. These would definitely get the circuit board up there. Nah. I'm not going to stack them one on top of the other. I think this is easier to do, and I don't need to make it too complicated on myself. That's 3 pins. Oh, here's a version of those, the long standoff pin headers that I have. How tall would that make this? Get us up there, actually. See if we can find 2 more of them at that height. I'd go back on everything I just said I was doing. If I could find just... Yep, there's 2 more. Let's just see. Let's just see how it does. I've got some really weird specialty headers in here from like a million years ago. So these are like special standoff headers to hold things a certain distance apart. I'll just humor them just to see what we're up against. This thing... Boot there. Maybe a little further back, but where's the other one? It's a little low. Ah! Darn it. Not very stable, understandably. Yeah, they're a little low. Shame. The humpy pins are very expensive. I haven't looked into ordering these. They just made it into my kit. Yeah, not tall enough. What about the big ones, though? I think these are too tall. Yeah, those are far too tall. Even spread out like that, it's like, ah! Okay. All right, just tested the waters. I mean, I could actually use that to flip this board around, too. And then it would be, like, exactly the right height. But it might interfere with the board above it. That would make it exactly the right height, though, if I did it that way. No, I really shouldn't. I really should not. I mean, the long pins with a socket, what would that do? Oh my god, dog's going psycho again. What is the matter, dog? She just will not suffer another being to be within range of the house. These don't hold on. They kind of let go of the socket. That's too bad. Make it look like a V4. What's a V4? What? I don't know what you mean. I don't know what that is. Well, if those sockets held on, then that would be perfect. And then I could keep this thing on sockets. It could sit above the thing. And it would be... Well, it would be lifted a little bit from there. But they don't make any kind of contact. Oh, 4-cylinder engine. No! I don't need it to look like... It doesn't have to look like a car. It doesn't look like a car. It's fine. That's too bad. That would have worked out, but those pins are too thin. These are unfortunately too thin pinned to actually go into the socket and stay. So this will be going to the side of it, and it will have permanent square pins holding it in. Here's 2 3-pin connectors that I can use. Well, one's silver and one's gold wash. We'll use the silvers. Those are kind of long pins. Wait a minute. Where did the one that I put to the side go? There it is. Yeah, these two match. Okay. So like that. I wanted maybe to have this thing on a socket in case it blows up. But it looks like I won't be able to get it onto a socket. Instead, it will go here. Like this. And I'll have a little double-sided tape beneath it to kind of hold it in place. And then it'll be probably 2 pieces of this stuff. Although one looks close, but this stuff is kind of thinner than you expect. Yeah, so maybe 1 layer of this. And that has so much surface area that this thing is never going to move. So even if I desolder the pins, I'm going to have more trouble with the VKB tape than with the pins. VHB, I keep saying K. VKB, as if it's a peripheral company from Russia. This needs to be cut a little bit back because that goes over the board distance. Oh, whoops. This feels wrong. This feels like I'm slitting its throat. That's a little bit more brutal than I expected to be with a PCB. There we go. And then we got 1 more layer of this stuff, because I believe that, like this, it won't touch. Yeah, 1 more layer is in order. You got 3 Ozempic ads in a row. What I hate is that we've cured obesity, and yet each shot is like $300. Can we put like public funding behind that? Because I'm not allowed to take it. Nor could I afford to. They don't consider obesity drugs to be like whatever it is, like vital to health or whatever, so you can't get them on a public plan. But if it was cheap enough, I bet you they would change that ruling, because it's like, dude, we cured obesity, like we did it. You keep telling fat people to stop eating, you know, mean forum people, they say just don't eat as many calories. It's like, well, that's what this does. It gets them to stop. It's doing everything you want, and you don't realize it. But it's a shortcut. Yeah, so's wearing like leather on your feet. Like, wearing shoes isn't natural, so should you not wear shoes then? All right. Aesthetic medication, yeah. Exactly, yeah. All the long-term health effects of being overweight, and yet they classify it as an aesthetic medication because for some reason we've trusted middlemen with the care of our health. And we just, yes, this is the best thing, that we have all of these people in the middle of actually keeping us from healthcare. That's the greatest thing. I'm so happy we came up with this. Oh God, I hate it so much. It's so bad. All right, we need to give this a little bit of breathing room. It needs one pin at least. So like that. Now that's inset just a little bit from the total output of this, but this'll be about even with the 3D print, I think. And then with 2 layers there, that's equal to there. And they are almost in alignment with one another, which makes my job just that much easier. I could put one more layer of the tape on it, and then they would pretty much be in alignment with one another. But then again, this square is also kind of an offset. So this is going to be a tough one for me to figure out on the back panel. I'm going to have to do a lot of measurements in order to get this right. Once I do, though, I will have my holes in the right place. And I could maybe even take this LED and move it over to an LED like right here. I don't know if I can fit one actually. Maybe over here, over here, over here. I could maybe do a separate one over here and just have the 15-volt LED on the side there. So it's not ideal. It does crowd out all the other stuff, but we can figure out a different solution for that stuff. Then I can put the power here. If I put power vertically and I put it as close as I can to the edge, there might be just enough room for MIDI. Nope. Nope. That doesn't work at all. Nope. Too big. Too big. Too big. Unless I scooch this all the way over. Maybe I got to do that. Maybe this needs to move all the way over. This moves over with it. Then the power switch moves over, and there's enough room for MIDI. Yeah, we got to do that. Okay. That's how it's got to be. That's why we don't solder everything down completely at the very beginning. So let me make room for us to get in there. I got to get these standoffs off. Then we got to move this power plug over just a little bit. That'll be an easy desolder. Easy-ish. I don't know. It's not going to be totally easy. We'll hold it up by this, and then I'll get the desoldering stuff. The desoldering stuff. This is going to take us a while to build. I mean, we know what the hardware is now. It's just going to take us a little while to get all together, just because of all of these little decisions that we've got to make. If I were doing this all on a PCB, all the decisions, boy, the whole process would be a little easier, wouldn't it? Nope. I'm not doing it on a PCB. We've got all these modules that are going in to make this thing up. I'm not going to 3D model all the modules and do all that nonsense. We're just going to put the thing together. I need to do a project where I just put a thing together and I don't make a big mess out of the whole process of creating PCBs and all the modifications and stuff. All the little foibles of CAD getting in the way. The temptation to come in and create a PCB is very real. Now, if you can't see what I'm doing, neither can I. I'm navigating this by feel. Procrastinating on learning CAD. It's a very useful skill, especially with the stuff you can get cheaply these days to create things. If you're going to be into making stuff, very, very useful. Even if you're going to make irreverent, stupid little statues of penises and put them all over your dorm room, like, it's, knowing CAD is super duper duper useful. I say useful, I do not say necessary. Now, if you're going to get into like engineering at all, it is necessary. You're going to be faced with CAD on a bi-weekly basis. But I didn't seriously learn CAD until after college. But that's just because of the era that I grew up in. Come on, give me the part. Give me the part, solder. The solder isn't detaching as I'd like it to. Not to mention, one of the pins I actually bent around the front of the PCB, so it's kind of sticking on a little too much. After growing up and sharing a room, I'm done with dorm stuff. Some people don't have a choice. All right, so with the plastic piece on and a standoff here, the furthest over I'm getting is just about here. So this links around the PCB. I did this in a weird way because this piece goes up against the portion of this PCB that has just pads up at the edge. It would be much easier if I had cut this and then redone the holes, and then I would have the parts being able to go right up against the edge. But not all of my parts are through holes. Some of them are panel mount, so wasting the space isn't that big of a deal. All right, so now this is scooched all the way up to the edge. Let me get this soldered down, and then we can solder down our USB power supply, and we will ore them. We're going to ore them with diodes. So that if you plug both of them in, nothing explodes. Is that all right? I think it's all right. I think it's all right. Of course, the measurements for these are going to be totally whack. It's going to be very strange trying to get all the holes to be in the right spot. One of the things about learning CAD copper is if you have like a task in mind, it'll help motivate the work. You know, like I want to model my room, or, you know, I want to model my town, you know, stuff like what Roboz is doing with his game making. He's motivated himself because he loves the kind of game where you build like a little, a space for yourself. And that's kind of how he's been treating it. And he's been able to stick with it because of that. I think that's a really good factor in it, is self-motivation through a project. Something that'll get you to return to it, and something that'll, even better is with a deadline, because genius is always spawned from a deadline. Something that's going to really make you crunch to get to know how to do something. Otherwise, it's just a thing on your to-do list forever. Part of why I stream. Like model trains with less initial cost. Yeah, and fewer foamies. You don't have people who are sort of ever advocates of certain types of CAD program. I guess maybe you do actually have foamies in CAD, because from what I've seen from doing this on the internet is whatever CAD program you use, everybody asks why you don't use the other kind of CAD. Yeah, FreeCAD and people who use Fusion are guilty of that both, because there was Emily Valinesco, who was on Twitter for some time until Twitter became not a great space for her, did work in FreeCAD, and everybody jumped in and said, why don't you use Fusion 360? And so she complained about that on Twitter, and I'm like, I had literally the opposite thing happen to me. I use Fusion 360, and everybody's always jumping in going, why don't you use FreeCAD? And I'm like, bitch, please. Like, I'll use whatever the fuck I want. This is my stream. All right, so we moved over the power plug, and now this can move over a little bit. Let's get in a little closer. There we go. That's the PTC that I had. I'm just going to get rid of it because we're going to use the big... Well, we'll test both of these and see which one at 15 volts knocks out sooner. We can run 300 milliamps through both of them and see which one dies at 300 milliamps. I think this one will die at 300 milliamps and the other one will hold on. I don't know how long the other one holds on though. I want it to actually be a safety device on this device, on this thing I'm building, but I don't know what its specifications are. We can look them up again, but I think it might run like amps, like many amps before it dies. Still be good to have. Paint is my anti-CAD. Had I not been using Paint on this, I may have already started building a PCB for it. So you better thank your lucky stars. I didn't use Fusion to plan out the schematic for this thing. Plus, I mean, I'd have to translate all these little boards into individual components. You know, if I were gung-ho about making this into like a product to sell, and I think the only thing holding me back from that is that I'm using the VFD display. Everything's a V acronym with this. VHB tape, VFD display. I can't think of any others. V-O-ring. Voring? Don't look that one up either. What's going on here? Well, that's a little further away. I need to move it up one row. Okay, so there's this and that. So now we have both of those right next to each other. They are almost parallel. It's going to be just annoying enough to get me in CAD. MS Paint Edit Design, mad. That is actually a very good one. If I do horizontal power switch, it still doesn't fit the MIDI connector. If I can somehow manage to get vertical power switch in here, it would have to be like this. There would have to be some extra material around it to push it out a little bit. It would still fit within the rails, but then I would have enough room for... Where did the MIDI plug go? Where did it go? There it is. Ah. So this would be here. And then that would barely fit at the same distance that the other one's at. And we would just barely be able to fit everybody in. So it's going to be a struggle, but I might be able to get all of my plugs in this side and still be able to access power on and off. Let's just check the height real quick. Just like that. Maybe I should get the knives out of the way too. All the pointy stuff that's going to hurt me. Just no room to operate. I mean, the other thing I could do is drop this down a little bit too. I could make that spacer a little bit less tall. But I think it's okay where it is. Come on, just stay still for 1 second. Jeez. Watching on Twitch and YouTube. You don't need to double dip. It's okay. I know my numbers are small, but you don't need to double dip for me. Yeah, see, if this is like right even with the outside, That's the only way that that's going to work, which means there's going to be a ton of material around it, which also means that the plug is going to need its special spacing along with this thing. So it's going to be like a recessed, there's going to be like a recess for this stuff, and then this will pop out. I also want to put this all the way up front. See, the post gets in the way. But if I put this all the way up front, then there's the power switch, and then I can recess the MIDI plug just a little bit with its buddies. So that'll be in there like that. Yeah, maybe that's the way we do it. And this is all the way over here. Yeah, that works, actually, because then I have all the plugs, and I've got the power switch all the way up front where I can get to it in the event of emergency. Watch both for when one goes on an ad break. There you go. It's a good way to get around it. Okay, so I'm gonna solder this thing in. That's gonna finalize that thing's position, and then we can test current situations with the two using some resistors, maybe some jumpers. And then when we come back on Wednesday, if I haven't already started, we can start designing the side panel and doing some of those iterative prints that will give us all of our sockets. It's going to be kind of weird, but I guess it'll work out because there will be basically a recessed portion, and then this will stick out to the front where there will be a recessed portion with the 3 plugs, and then outside of those, I will then have a part that sticks out to the very front where the main power switch is going to be. Better I put the main power switch in front. No. We already have our front panel, and there's no room for a power switch in the corner of that. I mean, as a piece of, like, test equipment, it probably would be more prudent to have a front switch and have the plugs in the back, but I think this will be more convenient because I can back this thing up to the back of the setup and stuff. I don't know. Everybody's guessing about everything all the time. Might as well join in. Anything and everything all the time. That just popped into my head because I said everyone. Just because I said the one word, it pops into my head and occupies it. Apathy's a tragedy and boredom is a crime. Let's get that aligned. It's still loose in the bottom holes, but I can at least try to get it a little bit straightened. And then I need to peel the tape and put this thing in the right holes. Challenge. When nothing is marked. Could I interest you in everything all of the time? Anything and everything all of the time. Apathy's a tragedy and boredom is a crime. Anything and everything all of the time. Yeah, that I kind of have a lot of that song memorized against my will. Here's what I'm going to do. I'm going to mark the corner with a little bit of solder, and that way I know where I'm putting it so that that tape doesn't screw me. Just going to mark that right there. Now I know what I'm doing. The problem with that song is that it's exactly in the key that I sing in. It's like the most comfortable baritone song. And I'm very much a baritone. Oh, we need to look at my glucose level before I... Hold on. Privately looking at my public glucose level. Ooh, something happened. What the hell happened? I guess my sensor's getting old, because when I went hyperglycemic, it decided that it could no longer... Either the sensor or the transmitter's getting old. And so it wasn't able to broadcast when I was hyperglycemic. And now we're back on the line, sort of, and bumping over it. So I'm going to see what it recommends we do. This morning, it was extremely weak because I was too far away from everything. Yeah, see that? It's very spotty, which means that my glucose level is probably high and it's just having a lot of trouble communicating. I'm going to put my phone in my pocket, but I'm also going to give myself some insulin here. Hold on. What do you suggest? Yeah, 8.45 units. So I'm going to give myself 10 units of insulin. Do not record. 10 units. And then I'm going to get a syringe and a needle. Let's see. Here's this. And here's this. And here's this. You're not supposed to recap these needles, even though I'm the only person that the needle has been inside of. When you recap it, you risk the needle hitting the edge of the syringe and poking out of it, and you're holding it there. So when you recap, it sometimes goes into your finger. Now, if you're careful, there is a method for recapping that you can do where you just do this, put it up like that, wiggle it a little bit, and then you push it from the top, right? That's the sterile way to recap a needle. And sometimes you need to do that because the needle needs to travel from where it's filled to the patient. But technically, you're really not supposed to recap because you risk actually penetrating your own finger with a needle. It's very bad. Anyway, I'm a protected class in America. I have a disability, so I get to do this on stream. Oh yeah, we're doing drugs. Get that sweet, sweet aspart. I got aspart in me. All right, anyway. That's 10 units injected, 10 units recorded. So now I have 2 hours or so until that actually starts having an effect on me. And I'll have to check back in with myself. I bumped the camera. How could I do that? Such unprofessionalism. Okay, so I've got a mark for the corner of the board so I can remove the adhesive from the back of the VHB tape. Not easy to do, though, sometimes. Sometimes it's not so easy to do. Then I'm going to have to go get my seltzer water and take a big swig of that because my throat's dry from being hyperglycemic and from talking for 2.5 hours. Where are my tweezers? Ah. They're buried in the fray. How are we doing for viewers? I saw as the weather got nice, we've seen some pretty big drop-offs in some channels. I'll take a look in a minute. You're not really supposed to worry about numbers when you stream, although technically some people get really deep into analytics with that sort of thing. Oh, I put it in wrong. All the preparation that I put into getting that mark into the right spot. All right, as long as it's close. Panels are all about wiggle room. Is the back touching, or is that... It's like barely floating in the back. So technically this thing is a little bit crooked. It's kind of leaning down just a tiny bit. But I don't think there's anything I can do to correct that. I'm just going to get my tweezers in there and push down on this stuff so that it makes contact. Yeah, it's just barely going like this. Oh, that's pretty good. Hey, Bad Direction, how you doing? You raining over there? Dude, we had some nice rain the other day. Although that was at night. But the weather broke, and so we actually can breathe now outside. It's nice to not be completely stifled with humidity by going outside. And then Mr. Zorin is out there complaining about the exact same temperature. He's like, oh my God, it's 75 degrees Fahrenheit. He's like 23C over there. He's like, it's 23C, I can't, it's horrible, I'm burning alive. And I look it up, I'm like, that's 75 degrees, dude? It's like, that's nice, it's nice weather. Scandinavians are built different, man, tell you. I got sent to the office today because I welded something wrong. To the office? That sucks, dude. Let's get the solder out of there. The upper end of room temperature. Yeah, exactly. Dr. Zool. Yeah, it's been unreasonably nice out. We had a LAN party yesterday, so we were all indoors during this beautiful weather, and we were all just like, we should really go outside. Like, we should do something outside. We need to do something outside. 27 here today. That's pushing it. That's the upper end of room, like what Copper said. It's the upper end of room temperature. But like I looked at the thermometer in my shop and it was reading 23.3, like 75 degrees pretty steadily, and I'm like, I'm actually not sweating at this. Although yesterday and the day before, no, the day before yesterday, the day before that, it was about that temperature, but the humidity was absolutely stifling. Like there was no breathing. 75F right now here. Yeah, if the humidity is low enough, it's tolerable, but I had to fix it. Then it turns out I did not weld it wrong. What the hell? Are you getting jerked around by like your seniority? That's what it sounds like. I think it's like 52 in here. All right, so, oops, where did that go? It's not dropped yet. I can recover this. So we have this thing. It's called a PTC, a thermally resettable fuse. It's two pieces of silicon that will become non-conductive at certain temperatures. It's more sensitive to temperature than your typical device, and it's a piece of silicon, so it semi-conducts depending on the temperature. So it will not allow electrons to flow if it gets too hot. Unlike a piece of wire that will become more and more resistive. I think more and more resistive. It's more resistive as it heats up, and that will cause more friction from the electrons traveling through it, and it will heat up and explode. That's a fuse. So these are resettable. When these disconnect, they'll cool off, and then they'll connect again. Guy yelled at me. It was the guy telling me the way to weld it. He hid most of the day, and I had the most productive day there. Jesus Christ. That's fucked up, man. So on both of the VCCs that are coming in, we need to put a diode on them, and then we need to mix them and put them into this PTC. Now that would live right here very nicely, and maybe I can go backwards with this VCC and jump it over to here. So maybe I'll do it that way. I'm going to jump this back over to here, and then I'll have my power in here. I'll have a ground right next to it that will have to, of course, wire to the other ground. And then those there will have a 2-pin plug, or a 1-pin plug, actually, that goes to the switch. Sorry, a 2-pin plug that goes to the switch. And then that will turn on and off the supply to everything else. So this will go here, but it'll have a wire that goes over to this area. Move that in a little bit even. So what I need is my 2 Schottky diodes. And these are tiny SOD323s. What is the BSO? This is a dual Schottky? Wait a minute. Hold on a second. Oh, this is for like mutable instrument stuff. Nah, I don't want to use that. These, I don't know what they are. They're larger though. They might be able to tolerate a little bit more current. Those are triacs. We don't need those. Silicon control relay. 400 volt SCR. I don't think we're going to need SCRs and triacs. 1N4148. Now, I think we're good with these. These are pretty tiny though. We'll have to see how they hold up to excessive amounts of current. Really, I should be designing a power supply, as in coming up with a topology for it and sort of known quantities and figure out what the calculations are. How much current am I going to need? Let's underball, or let's overstate it by a factor of 10%. But like that's too much like engineering, and it's more fun for me to just throw together stuff that I happen to have in the shop. What's the point of collecting all this stuff if I have to buy new things every time I build something? I know a couple people like that, where they're buying stuff a little bit too much. And it's like, hey, you should be dumpster diving more and maybe doing stuff more. So for oring a power supply, the direction that I want these to face is with the band towards the load. If the mistake was not found, I would have welded 4 out of 8 hand railing the wrong way. To what end, I guess, I guess it just would have been wrong. Not to spec. The engineers would have gotten mad. This pipe is the wrong way around. So our first stop before anything else is going to be the diode. Okay, that's a dog hair. Get out of here, dog hair. Now, you know, I want to give everything space to breathe, so I think I'm going to pull this to here. And I'll maybe put a little piece of jumper wire in this space right there. Just give everything just a little bit of room to breathe, and that way you're a little bit more sane. And that also gives this one a little bit of room to breathe. I can put it here, and I can have it come over here to this. I can have it go under the board over to that one with a wire. And then we can plug in the USB power supply, and we can see what it takes to blow the PTC thermal fuse. Now, PTCs are a factor of both current and time. So you exceed their rated current for a certain amount of time, and then it does not conduct anymore. So under 300 milliamps, that's probably a pretty safe current to run for it to blow out on the 15-volt line, which means that something is drawing more than an amp on the other lines. I need to align that a little better. This is it. This is the beginning of a very large system indeed. This is going to be a very large system for testing modular synthesizer modules. I'm not really certain that there's any demand for something like this. If I was, it would be really cool to put this thing together as like a kit or as something that I sell, and then there would be PCBs involved. I could sell them to people, but I don't think unless the it's going to be like the diehard fans of the show wanting to just give me money buying this thing. So we'll have to come up with like other kinds of like things we can do, like merch. And then I should put out sort of a comprehensive design on GitHub or something like that, so that people who wish to build something like this can steal my code. And then inevitably I find online that there's going to be this. See, what bugs me is that we've got these two giant pinheads going through such a small component. It goes through this tiny little component. I just don't know about that. I may want to use my other Schottky diodes. They may be higher current, especially for the first thing that this touches. These are a little bit bigger. I'm gonna use these. You know what? I'm gonna use these. I'm gonna use these. We're gonna see how these survive. I don't want to use those surface mount ones are fine for like 12-volt systems for modular synthesizers, but these are slightly larger. They'll have slightly higher current specs. Let's get rid of the other one and let's replace it with one of those. The voltage specs seem to be on par, and this says it can handle up to an amp, but I just don't. I don't like it. I don't like it in this spot. You get out of there. You're fired. Tweezers? There. Under the iron. That's a good one. I do actually have a whole thing of diodes, a whole package of diodes, but maybe I use these. I have a little thing that has Schottky diodes, and some of them are higher current ones, and I've got part numbers. So if we're backed into a corner, I can go to those. Watching an eBay auction for a week, the reserve still hasn't been met. Went up to $100 for $20 for an item sold. The listing was for $160 when mint. What do these guys want? They want to not get a bad rating from somebody. That's what eBay's all about. Soldering iron. I use a Pace ADS 200. It's a 300-watt soldering iron. It's a little bit weird this day and age because, you know, irons have moved on. There's, oh, God damn it, hold on. There's all kinds of soldering irons out there, and I've just used this one for half a century, so this is just the one that I like. I also solder stuff a lot, and for the home gamer, this is a little bit much. But having all this wattage is nice. you can get this much wattage out of one of the newer consumer ones that are like much cheaper. I have the JVC at work. I'm trying to find a cheap one for home. This is like a $300 soldering iron, but it has the quick swap tips and stuff. I don't really know what I would suggest though, because this is just, I don't know, I have the nice equipment. FX888D, never heard of it. Never heard of that one. There's one slightly larger Schottky diode. I forgot that I had that kit of surface mount Schottky diodes. I should look at that at some point. Maybe those would be the ones to use. Well, we'll see if these get outpaced, then whatever. We'll go to the ones in the kit. Okay, and then this one down here. I'm gonna put this one just right here up against this. We'll have to look to make sure that these don't get super hot in their use. Fans right there, so I'm going to flip this one around. The TS80 and the TS100 and the knockoffs are also particularly favored of the people in this channel. They've talked about them quite a bit. And they seem like pretty nice ones. I have a TS100 in my tool drawer, the tool chest for tools that I rarely use, and I've had nothing but good things to say about it. It seems to get hot just about as fast as this one does, and it can mostly handle the same stuff that this one can. There's a very rare occasion when it does not. Good news about becoming a welder. Now I get to throw away all my rusty scraps I've collected for years and take fresh, better materials home and make stuff. My garage has become even less messy. Hell yeah. Oh God, I need sheets of metal. I need sheets of metal to fix my frickin' car. BMW decided that the coolest place that they could possibly drain the sunroof drain and the hood, the windshield drain, was to drain it either into the windshield wiper or down and into the, what do you call it? Blah, blah, blah. Into the skirt, in between, skirt under the front and rear door of the car. Yeah, the sill. But under the car, there's this hollow piece of metal that's part of the unibody, and they drain into that piece of metal. And that piece of metal is right where both of the wheels are. So the wheels kick up debris, and it gets into there, and then that thing doesn't drain completely, and it rusts. Absolutely the worst. 20 years experience is a lead to some great jobs. Yeah, welding. I tried my hand at welding. I did not do very well. I need more experience. Need more seat time. Battery soldering irons used to be a joke. Yeah, they're powerful, aren't they? Now they're just a big lithium-ion battery that you plug into stuff. Do I use this stuff to do the power supply lines? I think this is a little bit much. This is a little bit much for the power. We're doing like hundreds of milliamps. We're not doing amps. What wire can I use for this? What can I use for this? I need to find scrap wire. Into the scrap wire bin we go. I have stuff that's way too thick. What the heck even in? What is that? Big AC fans for some reason. Foam. Cool, good thing that's in there. These IDCs should not be here. This has become kind of a dump for a little while. An air pressure gauge? What is that even doing in here? Hold on a second. This is the wire bin. This is not a wire. This goes over here. This is shielded. It's like cat wire. Yeah, this has a center conductor. This might be what I use for the audio signals inside of this board. I need something that's like a slightly lower grade, but solid core. I don't think I'm going to find what I'm looking for in here. I should probably buy some wire, to be honest. To be honest, I should probably be buying some wire. I used to have all kinds of weird solid conductor wire, but I've gotten rid of a lot of stuff. Yeah, I don't think I'm going to find what I'm looking for. Nah. Nah. Oh, stand up, stretch my legs. Sheet metal, I get it off the file cabinets for gym lockers. Don't know if you can get that free cheap over there. That's interesting. I don't think I can find that kind of stuff. Maybe I know some people who can. That's how in the game Abiotic Factory you get a lot of your metal. It's from file cabinets. It's not a pile of hay. I know what meme you're talking about. We could actually use these. Might as well. Go to a train track. There's plenty of wires on the streets there. I don't know if I trust the chat's advice. The Sony dictation cassette players. Is it the cops? Is it something the cops use? Oi, it's the Roses. You want to buy tape recorder? All right, let's see. Let's get over to there and then cut this one like this. How far do I want to go? Maybe to here. I'm going to need the wire stripper. I'm going to use this stuff for power line. That's getting scraps from builds, and then you have a couple shells of wires. That's nice. Yeah, I used to be able to get odds and ends from shops that I worked at, but that ain't me anymore. Now that I'm streaming and doing less contract work, that ain't me. I think people are walking dogs outside because it's so nice, and so my dog is going psycho. All I hear is woo, 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 woo out the door. These seem like they break off kind of easily when I strip them like that. I got to be careful of these wires. They're very cheap. She's being a woo girl right now. So that's coming from here. Ah, really? I'm off by 1. Are you kidding me? No, I'm not accepting that. I just can't. I can't believe I got that off by 1 hole. Maybe it'll be useful somewhere else. So from here, and then I need to just give it plenty of space here. Going to that one right there. There. I have enough of these these breadboard wires that I think I can do a lot of this wiring with these, and then it'll be clear what's going on if I color code them properly. I can use a lot of the excess ones that I have. Hello, is it me you're looking for? I can see it in your eyes. Damn it, Jacose, it's stuck in my head now. You bastard. Bend down the little end of wire here so I can connect that. You started it. Damn it. This is mutually assured destruction. Will not stand for bullying from the Scandinavians. Their neutrality is too much for us. All right, so... Actually, no, that's just the Swiss, isn't it? All right. Micro sprig arm. We got to travel for many thousands of miles. Oh, no, there we are. Okay, so there's that one, and there's that one that I need to solder. That one's a little long, but we can deal with that. That's fine. That's fine where it is. Be a little sloppy. Everything doesn't need to be perfect. What have we done now? What haven't you done? You know what you've done. You just know. I'm going to cut the little end off of this, and then it'll be able to straighten out just a little bit more. Or not. Or this is not the best blade for this. There we go. We almost had surströmming for one of our LAN parties, and I told them, I'm just like, I don't feel like puking, because their understanding of it was to get Russian surströmming, which I've never heard of it being Russian ever, and then they were going to open it in open air instead of putting it underwater first. Because really what you're supposed to do is you put that can underwater because it's going to continue to ferment while it's in transit to wherever the hell you are. Whatever non-Scandinavian area you're from, it is going to continue to ferment and it's going to pressurize. And there's going to be a buildup of pressurization, CO2 in that can. So that's the prank, is people are like, I'm here in my car and I'm going to try surströmming, and they open it up and they spray the interior of their cloth interior of their car with rank shark CO2. So, you know, I wasn't about to stand for that. They were going to open it outside in the garden and probably proceed to puke all over everything because of the heavy, heavy ammonia that they would then have to breathe in. Refuse to try it. I don't think it's as bad as everybody puts it out to be. You're supposed to open it in the sink where it'll control the stink, and then you put it on like a cracker and you just, you know, it's this heavy ammonia-y kind of stuff. I think I would not hate it. I don't know if I'd say like, but it's not what? Ammonia-y? I thought that was the whole profile of it. It is kill it with fire. Prep it properly and it's fine. That's what I'm saying. I think it's one of those things that's blown way out of proportion. I also need to solder these together. Dude. I can do that in just a second. Yeah, I'm just like you guys. I have my fish juice in the morning. My hot fish juice. Hot cuppa fish juice. Someone needs, no. You guys do not need to send it to me. I don't think I'm equipped properly with the fume hood. I have a bottle of fish oil. I do actually take a fish oil pill, but I just liked Gonad's proclamation of fish juice. Have a cup of fish juice. Have another one. All right, we're putting a corner wire in here. Want to be consistent with the wire size because this is going to be pushing the most. Well, actually, it's not that much because it is going to be 15 volts. It's really the 5-volt one that's going to be pushing the most current, and that's only 100 milliamps at any given point in time. Let's talk of scrap metal reminded me of a book posted on Discord and car stuff. Now I need the book to start to collect the right bits. What's the book? The Kelly Blue Book? That's sticking up in the air. Hold on. We got to get them all at once. Push that vertically just a little bit. Wrap it around. Damn it, I don't think that worked. No. Why did I lose that connection? Oh, because there's no post there. It's just that. Haha! I'm the wiener. Fish sauce is when they just throw the fish in a barrel for a few weeks and then squeeze it. What? No, 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 no. No, 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 not like this. Not like this. Nasty. Maybe that's fish sauce from where you're from. I don't know what I would consider fish sauce around here. We use stuff like oyster sauce where you cook the oyster for quite a long time. It's actually cooked. It's not like just the juice of a fish. It's not... You maniacs. Build your own sports car on a budget Haynes manual. That's kind of cool. I have a dream, and that's one day to buy some kind of a crazy, like boxy 80s car, and then put a Model S transmission, both the front and rear axle, into it. I would love that as like a battery operated grocery getter, because like my local grocery store is fairly close by, and it would be awesome if I could just jet out to it on an extremely fast. I hate to have to allow that. Jacose, I hate to have to allow that. There's rumors about how oyster sauce started, and the biggest rumor is that it was a bunch of oysters that were cooking in a pot, and it was left for too long, and that became the beautiful fragrant fish sauce or oyster sauce or whatever that you use in a lot of Asian cooking. That stuff is delicious, though. It's not nasty. That's delicious. Oh, bother added the permit term, Asians are nasty. I'm so sorry to have to allow that term. Ew. Build your own sports car on a budget, Haynes manual or Lotus 7 or low cost. Well, it's in the name. All right, so let's see. Ground. Ground to ground to ground to ground. Why are there people running around over here? Somebody has had to come downstairs. We're getting ground from over there, or from that pin. When we plug in the ground, it cuts off the further... No, it cuts off the closer pin. That's how the fish sauce is made. I know it. So we basically connect these two pins to this further pin over here. So I'm going to use, I guess, a black wire, but I'm going to put it on the top of the board. Maybe under. And then I can skip over it with the, or do I even have a black wire? That's the solid kind of wire. I want to use this stuff for power exclusively, so I don't think this one will do. Too short. Yeah, I have to come from above on that. We could just do it like this, actually. Yeah, that's fine. That'll do. So put a little bend in one end. And that's our ground connection from one to the other. And I believe that's the one that cuts off. But I don't think it matters if it cuts off. What are you okay. That doesn't bend soon enough. Let's see if I get that. Diodes in every micro ground wires are out. That's too much. No, you don't need that much. Oh wait, I'm not going to that one. I'm actually going to the one, either the one that's on the side here or the one that's underneath. I think this is the one that permanently connects. Let's just double check that. Let's double check that. I forgot where my wires were. I maybe don't need the I can still use the black wire, but I don't need to like drop it down. I can flatten it up and solder it, skillfully solder it right in that little opening right there, but I need to just check. Go to ohms, plug in one of these things, bonk, and then check to see which one is still connected. Whichever one isn't connected is the one that I solder to. So minus wire here, and then check this one. OL. So that's probably, well, actually, I don't want the one that cuts off. What am I talking about? Because when I plug this in, I want this to still work. So, yeah, all right. If I wanted to, I could route this ground through that pin, but there's no point in doing that if we're using the O-ring diodes. So I might as well connect to the one that permanently connects to ground, which is going to be the one under the board. From here to here. To here. To here. To, okay, to here. Here. To here. To here. To here. God damn it! Is it? Yeah, maybe this one's minus. No, that one's definitely plus. And then the big one is minus on the battery. Go right to here. Yeah, so this is where I want my wire to connect. We're not going to bother with the switch that's inside of this thing. Okay, so one of these wires that I haven't bent yet. And I guess it is going to be under the board. But what I'll do is I'll run it like from here. It's right next to that one. I guess I gotta go one further forward. Well, that blocks the thing. I don't want it to block that. Ah! Sorry, I'm doing it like this. Hard to see what I'm trying to do here. Guess I can go under the board if I need a big ground connection. And plus, we're not even going to be near an amp for this thing, so this will be fine. This will be fine. And then this somehow needs to go to that, which is going to bend. I'm going to bend straight over. Let me get that standoffs out of the way so I can actually get to this. I never get that. I never get the early in the morning thing. I always get, we're sorry your package is still arriving. It's always late. It's like, or they don't ship it for 3 days. Your delivery driver exploded. Like, oh, that sounds bad. Oh dear. Yeah, he blew up. Very tragic. He just exploded. Bonk. This thing over here. Actually, shipping around here is way more consistent than I think it is with all of you guys. I'm in a densely enough populated area that things typically happen the way they're supposed to happen. Yeah, 2 days from after it ships. And then you always make the mistake of going through the listing a little too hastily, so you never catch that detail. That's my affliction. Not paying attention enough. This will be our big ground blob. This wire is kind of cheap. It's a little bit difficult to solder. There you go. It's pretty good. This, of course, can go to either of these, and I guess I'll just put a piece of bare wire horizontally across. Yeah, I have tacky flux. It's called tacky flux. We don't need any. There was a little bit of solder braid that I cut off earlier, and it should be somewhere on the desk, because that would be very useful in this application. I mean, you want your grounds to be big, wide, and in charge, but I guess I don't know what happened to it. Is it over here with all these dregs? Usually I keep them somewhere on the desk until it's time for cleanup. That way I have solder braid for exactly what I'm about to do. And I guess I'm going to do it with solder braid anyway, because I want to show you guys this technique. But it would be good to do it with scrap. I don't got no scrap. All right, so let's get a little piece of solder braid from the end of used solder braid from the end of the solder braid. This stuff right here. Typically you would discard this, but in our case, it is a perfect thing to use for just a little ground strapping. Just like that. We'll just put it right there. And then my dog goes nuts. What is she barking at? What could possibly be so important? Okay, that shot off, and I heard it make a little clink noise. There it is. No, wait, this is the stuff I discarded. I just found it. Where did the piece? Oh, there it is. So, of all the places that went, I cut it here. It went poof, dink, and then landed all the way by the keyboard. There's a little piece right there. Stuff can tend to go everywhere when you work quickly. So this would normally get discarded, but now we're using it as a big old trace. A fellow solder soldier. It's especially useful if you have a very high current power supply and you need high current traces and you can't fit them. You leave a solder mask open that's the width of a thinner solder braid, and then you just put solder braid over top of it. And all that extra metal and solder makes a much thicker trace that won't heat up and expand as much as if it were just the copper substrate. It's just stuck. It's just permanently, no, okay, it's not permanent. All right, let's get this over here. That's a trick that I did with the big high current 12-volt power supply computer with the traces on that, because the PCB from Seed Studio was only a certain thickness, and I needed to have much more current running on those traces. So I took desoldering braid and I did. This is an old RF engineer trick. And I don't need that much current in this trace. This is kind of overkill, but I'm doing it to show you guys the trick. Yeah, you can really beef up the PCB traces. You just got to make sure that it's not going to expand and flex your board. That's the death of the PCB, is when your board flexes. The dog's still barking. Willow, shut up. I'm trying to talk to chat. She was downstairs for the very beginning of stream. I think she wanted to take a nap down here while I was sitting at my desk. But then I started to move. The audacity that I had to start to move around and set up for stream. So she left in a huff. You know, I could do further flattening down of that, but this is just some amateurish, stupid thing that I'm building, so I'm going to leave this at that. How's the doggo doing? She's doing great. She's very happy. She saw her friends. She was completely just morose while I was away with my friends. She was sulking and everything. When I came home, she was like attached to me at the hip. She's cute as ever. Short oscilloscope grounds. That's interesting. So what we're building right now is the power supply, but what's eventually coming out of this thing is a 6-channel, fully featured modular synthesizer testing module. Now, I would have gone with 8 channels, but I don't think I need 8, and I don't think I need 8 inputs from anything. So we have muxed 2 input channels that are selectable on any of the I/O. You only have 2 inputs. All 6 of these can be used as outputs. They can be used as gates, they can be used as triggers, they can be used as audio frequency, they can be used as low frequency oscillator, they can be used as anything, because the modules that we have on them are 2-channel I2S muxes, or sorry, 2-channel I2S digital to analog converter chips. They're really good. They're used with like I2S systems. We're using a Teensy 4.0, which has an umpteen billion amount of I2S on it. Now, if I actually used like an audio codec on this thing, we could have had 8 channels, but honestly, I think 6 is fine. So we're using this thing, we're using I2S, we're using its one 2-channel, or sorry, we're using its one 2-channel input, and it's 3 out of 4 of the 2-channel outputs. There we go. You make a circle with the braid and put them around your probe ground. Solder the other end to the PCB ground. Circle with the braid. So you mean like a loop that you can clip to? It's interesting because that's like a big loop. The there are actually also components or through-hole components that you can solder to the board that are just a little loop of wire. Mom's dog just got surgery. Oh, it's a poor thing. Got that whole thing removed. I hope for a speedy recovery. You just clip everything to it? Dog is going nuts at the door. And then somehow people think that making more noise will make the dog quieter, which is not the case. Clapping and banging around is not going to make the dog quieter. Is that too heavy of an angle? I can see the angle from here. I don't think one more piece of VHB tape is going to do it, though. It needs to be like right there. There's nothing I can do. Just going to leave it alone. It's on our way to a full recovery. That's good. This will bother only me, so maybe I shouldn't do anything about it. We'll just have to extensively measure where this ends up on the panel. All right, so we bust our powers and grounds together. Now we can hook up to VCC and ground with a load and see what'll pop this thing. Yep, all our powers and grounds are together. And so I need to connect this guy, and then our main power output is coming out of that. So that's going to go into the 12-volt regulator. Should I do that surface mount? I guess it probably needs to go across the surface. So if I bend the leads horizontally, I guess that's what we're going to be doing here. And then we'll test this puppy out, see what it does. All right, that's going to be a big old solder junction. Where's my, okay, I use a miniature precision vise to kind of hold stuff up sometimes. I'm going to solder this over here. So right now what we're doing is sorting out the 15-volt power supply of a modular synthesizer module tester. And then we're going to test to see that under load, this thing is able to pop off properly and we don't break anything. Although I don't have a 15-volt brick that I can test. I guess I have my other one that I can test and try to plug them both in and see what happens. I don't really think I need to plug them both in. That is hot. Owie, owie, owie. My way to master's in electronics engineering. Then you should have understood a little bit of what I was talking about. I only have a BS in EE. I tried for all those masters, like the math tests that you have to take to back in the day. I don't know if they're still using them a lot of places, but I tried learning the math for those tests, and it was all just those little stupid math tricks. Like, oh, you know math? What happens when you do this really specific thing? And it's like, what the hell is this? Yeah, no, cat. Sub with Prime for 12 months. Thank you, Nano. People, yeah, the electrical engineer has forgotten more math than you've ever learned. I was robotics and control systems. This is going to hurt. This is going to get hot enough to hurt. Nano, thank you so much for the 12 months. Full year. Owie, this thing gets hot very quickly. This thing really freaking hurts. Yeah, I did control systems math, so I've known some pretty heady math in my day. Pretty heady math. Tweezers don't hold on to stuff like that as well. I just don't like how this looks like it's floating above everything else. It's just sticking up too high. It doesn't quite look like a good solder joint. It should be right up next to everything. Maybe we'll get this one soldered and come back. That way I don't have to hold on to this thing. And I don't need it propped up because I bent the wire underneath the board. So now I can get good focus with the microscope. Really see what we're doing. Just push down on everybody at once. That's a little better. A little flatter to the board. Now I gotta let this cool down. And I've got over here 300 milliamp, at least for 12 volts, load. We can test that with USB power. See how if our PTC will cut off current. I guess I could have tried that with the power supply. Would have known. Let me put this rail back on so it's not sitting right up against the desk. That way we've got a little bit of space there. Where did it go? There it is. One of the challenges here is that I've got so much stuff going on. This project is a lot of hardware. It's a lot of hardware. And so I have to keep all this hardware together as I work on various facets of the design. That's one of the harder parts. We're moderately confident that every piece of hardware here works together. So if you were to explain it in ones and zeros. I don't know about that. I don't know if I speak that language. I don't think finger things are going to help. Plus, they're just annoying to get on and off. Yeah, these distort the board a little bit because they're the 3D model that I got of the PCB had slightly different holes, so everything's just a little bit off. So, I mean, I can load this thing up with 300 milliamps from ground to power and see if we can get the PTC to stop working. Problem is, I don't know when the PTC stops working because I don't have a current monitor on it. So let me get a current monitor. I mean, I could use the little low side current monitors in order to nah, we'll just use this. Where's it? DC amps. Oh, I see. DC. Yes, I know lead. From here, hopefully that's making good contact. Here. And this is 28 ohms with 15 volts. And then this is vaguely ground. Should be ground enough. And then I have a power supply here that's coming from a $75 high current USB-C fully supported power brick. 3, 2, 1, go. That's not quite powered yet. The LED did not turn on. Oh, it's not plugged in back here. Hold on, gotta get the cable back here. Oh my god, my dog will not shut up. It's a nice day out, so all of her friends are out. And she's gotten a little bit too used to barking at everybody. I don't know if maybe we need to like start trying to train her to shut up more. Or if we just have to wait until she gets lazy. Old and lazy and doesn't care to bark at her friends. Because every time somebody walks by in the neighborhood, it's time, she's like, I cannot believe this transgression. I remember the days before Amazon and breakout boards. Well, aren't you special? I used to print on printer paper schematics, or sorry, data sheets from my school's library. They hated me. All right, 3, 2, 1, go. That's not .03. That's a bad connection is what that is. There's people in chat younger than Amazon. Back in my day, Amazon was a bookstore. Oh, that's V+. That's not the right connection. This is ground over here. I was going to say negative, but it'll still be the right amount. And the question is whether or not that PTC gets hot enough to cut off. So we're almost at 500 milliamps going through this thing. And everybody's getting warm. Except maybe my PTC. You were supposed to be the chosen one. You were supposed to thermally cut off. Instead, this thing's getting hot as hell. Oh, not really, though. It's quite cool, Mr. Frodo. It's actually not hot. It's just the relative heat. That's getting quite warm. But I wonder if this thing will cut off at anywhere below like an amp or two. An ampersand. An ampersand's undertale? All right, so let's go higher than that. Ground is there. And then we're going to go to double the current. I said double the current. Double the current? Double the current. Hello? Lost the connection somewhere. Probably the wire down here moving a little bit. Yeah, that wire moved. All right, so let's take this one instead. Drive that one down here. Make contact. This one goes on the ground pins. So just put it between the ground pins and put a little pressure on it. This is a very haphazard way to test this. I probably could get different test leads on this thing, but whatever. And then connect in here. 900 milliamps. Come on, thermal protection. It's heating up. I see it heating up. Let's see if that 900 drops off after a couple seconds. Also, this thing is heating up in my hand. Actually, it's kind of hurting my hand. Oh, this is the cold part. Come on, thermal protection. It is getting warmer. 979, 980. So we're pulling an amp, and it looks like the thermal protection is getting warm. It's possible that if I go over an amp at 15 volts, it'll cut off, which is what we want. This is actually working out a lot better than I thought. Is that PTC getting hotter, though? You can see the 9. You can just barely see the 9 on the thing. I can't really move my hands much. I got myself into this test setup, and now I'm gonna cramp. I'm gonna get cramps. Breakout boards like an addiction. Yeah, I could see that being the case. I mean, I could have, I could have taken this whole design. I could have. Welcome to Philadelphia. I could have taken this design and put it all on its own PCB with all individual modules and stuff. But like I grew up in a research environment. I worked on some old brain imaging stuff that was at the UPenn labs, and this is how they did over there. They use modules for stuff. Because, you got to get the job done, and it's just so much easier if your main PCB is just going to be connecting a bunch of functional modules together. So we're taking a very systems engineering approach to this. This is heating up. I'm feeling the heat off of these resistors. And yet, down in the corner, that PTC is not showing all that much different in heat. I think it might have reached an equilibrium. It would have been good if we taped a thermometer to it. Everyone does PCBs nowadays. It's nice to see people hand wire thing. Yeah, well, my hand wiring is so sloppy. And to be honest, like building a PCB for this thing would have been pretty cool. Even just as modules going together, building a PCB, they're so cheap that you just don't need to do this anymore. Like both. I always break down in the middle of one of these things and then build a PCB. This is starting to get really hot. I'm going to have to move soon. Ow! Was that it? Damn it, I slipped. That was on me. Okay, so this thing can push an amp pretty far. And if it pushes an amp, then this gets warm. That's not even warm. This doesn't even get warm right here. So now we're going to push more than an amp. I'm going to have to distance myself from this a little bit because I just don't want to burn myself on any of this stuff. Even these wires might get warm, but we'll just see. And this might explode. I don't have any worries about the power brick. The power brick is barely warm. That thing can handle quite a bit of current. So let's just set up the camera properly so that we can take a closer look at the PTC. And you guys can see the current rising in the background. Actually, they're going to struggle to get that thing close enough. We'll do this. Yeah, there we go. Oh, come on. You piece of shit fucking thing. Come on. There you go. I need that angle so we don't get all the glare on it. Actually, let me just do... Nope. Not really. And then this goes up here. Owie, it's still hot. Fuck. Okay. There. And then... the more we work on stuff, the more I get pushed over to the side with the project. All right, so we're looking at heat through this device right here. This thing right here is a thermal cutoff. If this gets too hot, it should turn off. I should probably bend it and put it on top of this thing, but this is supposed to be getting hot in and of itself. And once it gets too hot, it will stop conducting until current is removed. And to hold the ground on, I need to put a little bit of pressure on this wire here like this. I could probably invent a better hookup for that, but we're just doing this haphazardly. Yeah, a clear space will attract objects. So we should see a blisteringly large current coming through this thing. No, not yet, I suppose. Ah, this thing's still hot, very hot to the touch. This might have come loose up here. All right, I'm going to get alligator clips for this because that'll just make my life a little bit easier. Alligator clips. This will be our hot wire. Goes to here. I need 2 more. One is for ground. Hold on, I gotta go get them. They're on my wire hanger. They're all the same color. Take these 2. This one is ground. Like ground goes to, yeah, ground goes to the load. I'll just clip in directly to the load like this. And then, so we've got that running through there. And then this one goes to whichever hookup I want to be pushing power through. So many wires. Most memorable project is Burn the Subs. It's a giant laser etching table, quote unquote, that sits on the wall behind me. And we're going to get back to that soon. We're going to get back to it soon. It's sort of the landmark project of this shop. It's made me quite a bit of money in the past. So the more it's down, you know, the worse it gets. Wait, I didn't connect anything else. Hold on a second. Oh, this is on the wrong one. Hold on. I got this. But it's a Twitch API powered laser etching table that Twitch never really acknowledged it, nor did Hackaday, which is kind of burns me a little bit because I wrote for them. Yeah, I still have the boards that were filled up with ridiculous Twitch names. All right, now we're running 1.3 amps to this thing. Cut off, you son of a bitch. Why did this break? I lost my focus control. Does that work? No. It looks like a Stream Deck froze. Start up Stream Deck. So, I mean, this did negotiate for the 15 volts, and it's pushing it through the rest of the system. But what's not happening is we're not getting a cutoff. Our diodes, our Schottky diodes, are starting to heat up a little bit too much, too. We should still see a cutoff. All right, this resistor's starting to burn up. I'm going to cut this test off. Cut the test off. Everything's too hot. Everything's too hot. I'm starting to burn something. Something's starting to smoke. It's not this. It's probably the VKB tape, actually, that's getting too hot. That and this right here is burning my probe lead. Well, not so much, but maybe that's what's smelling. That's why I put it on top of the heatsink. All right, so nothing's going on there. The alternative is using the little surface mount PTC. I guess we can set up to test that one too, because like that should have saved us in this case. We gave it about 900 milliamps, so it was at about an amp for an extended amount of time, and nothing really happened. Back when I was a kid, I used some telephone wire jumpers for creations. Yeah, those are pretty good. I don't, you know, these do the job. Sorry, I don't have a lot of control over the computer right now, just because the test setup is all over the mouse. I don't have any room for the mouse. You know, I've put that PTC, this thing, in other projects before, and it just hasn't done anything. I'd like 12 to 15 volts. I just don't think there's enough stuff running through it. I think that's more of like a 120 volt kind of thing. I gotta let everything cool down, though. That got way too hot. Let me unplug 15 volts from this guy. Bonk. At least we know those O-ring diodes can go up to like an amp. Hey, Brink GG, how you doing? What's going on? All right, what's my glucose level doing? Spotty. This sensor is not long for this world. It's jumping all over the place. I think maybe I may need to change out the sensor. It's on my shoulder, so I might have bumped it. Nobody said they want open circuit. I know they aren't fuses, but they're resettable. They're called resettable fuses. They're called that. At any rate, we should have seen a drastic drop in current running through it from what normally ran. That's all I was claiming. Why do you have to do this? Back off a little bit. All right. So we can try the other one. We can try the other resettable fuse in the circuit and see what it does. But we do want this monitor still. Unfortunately, this is the best monitor that I have right now for this sort of thing, so we don't quite have a choice of our setup getting any cleaner. We can't test the other one, the little surface mount one that I had in this section of the desk. I don't know what happened to it. It got shuffled around. It's just going to be kind of buried under stuff. I'm going to poke around and take a look at where it is. But then I think when we come back on Thursday, I can clean the desk a little bit and we can 3D print. TrueNAS has released the beta for the upcoming Docker-based apps. Planning on testing it Wednesday or Friday night or Saturday morning in the airport. New public release should be soon after that. You don't have to test it at the airport. I appreciate dedication, but I'm not gonna. You can take a vacation if you need to. That's really cool, Brink. I'm excited to hear what you think about what's going on with that and where I can go, because I was considering plugging the Raspberry Pi back in and disabling like Node-RED, turning off Node-RED and cleaning that up, and then running Node-RED off of the Node-RED off of the file server, and then having the Raspberry Pi still plugged in as the broker just for now. And then we can continue with burn the subs a little bit and get some of the other functionality out of it. We can get Node-RED to actually do the vetting out of point redemptions and sort of divvying that out to other components in the shop. Because that is going to allow me to very quickly spool up some kind of a chat interaction if I need to. This is from my own writing. I got to let all the people know how it goes. Nice, nice, nice. I hit back on the mouse. Did I ruin anything? No. Okay. So I had the other PTC element sitting somewhere out on the desk, and it is a surface mount component. And I've been working with stuff for a bit here tonight. So naturally, it's gone. But I think if I look around carefully enough, we'll be able to find it again. Is it stuck to this? It is. It's actually stuck to the neodymium magnet that's on the multimeter. Actually, bother, it's neodymium. Bother, that's actually what it is. Get it right, streamer. Okay, so I don't need the test leads on this thing. Let me get rid of them. Just makes more mess. Just makes more mess. All right, so clip leads from here, and let's get this out of there too. And I'll put the surface mount device in its place. I've never gotten a chance to really test these ones that I've had, these through-hole ones, but it turns out they are meant for much higher voltages and currents than what I've used them for in the past. But man, this thing heats up quickly when you put a soldering iron to it. Seems like if I wanted to make sure that something else remained cool and allowed current to flow, I could use this thing. Also, I can't get a good grip on it with the tweezers. Whoever suggested the tweezers, you're completely fucking wrong about being able to handle this thing with tweezers. You're beyond wrong. There it goes. Why is it not coming further out? The fuck is good? What are you doing? It's just that. Ugh. God fucking damn it. Why was that so difficult? Jeez. I've learned that tweezers require a part of the brain I don't have. I handle leg with tweezers, not body. If you continue to use tweezers, they become second nature. That's how I am with them anyway. They are like a second set of hands. I am useless without the tweezers. They may seem clunky at first, but if you have the right types, because if you have pointy tweezers will tend to want to go like this and just go off axis with each other. The nice big wide dull ones are much more controllable. You gonna grow hair on it if you don't use it? What? Okay, so moving this thing aside, moving this way, we can now go back to the microscope. And I can contemplate where I put the PTC that we were... There it is, I see it. Deepest, bluest. My head is like a shark's fin. Not having any issue with them going cross-legged. With longer tweezers, they tend to do that, but I don't know. I've had troubles with that. The problem with this is that I can barely get it to cross these two. There. If I ride it up like this, that means this is sticking up in the air a little bit, but now we have that pad right there. Pliers? Pliers seem kind of like a hammer in a china shop. They only go crossed over if you drop them. Maybe I'm gripping too hard with them. I don't know. Everybody is a counterexample to literally everything I say. So, like, go fuck yourselves. I know what I'm talking about. It's my show. Jewelry pliers. Ah, okay, so those are on like a different level of smallness. Yeah, jewelers' tools seem like they would translate really well to working with electronics. No, see, if you say that, they're then going to come out with, yeah, well, there are smaller sledgehammers, you know. Like they'll be like, I've been using sledgehammers for 1,000 years to frame houses. I'm an 18th generation sledgehammer house framer. That's what Twitch chat does, and it drives me up the fucking wall. Because I'll say something definitively, and there will always be a counterexample. And I'm like, look, you have this corner example of it being useful the way you described once. The same thing with lead. Lead is not good. Lead helps you solder stuff sometimes, but it's not totally necessary because the formulation of solder has changed over time. And the unleaded types of solder are much better than they used to be. It would behoove you to not completely expose yourself at all times to solder. Now, can you believe that I got backlash from that? Because the level of research of your average person on the internet is to find a singular article that proves them right, and that is the breadth and width of their research capabilities. They find one article that says, we did some tests, and we, the lead consortium, found that it was totally acceptable to be exposed to what they describe as quote-unquote dangerous levels of lead in your workshop. And they go, aha, I got you, bother. I've proven you wrong. The oil companies released a paper that said that it was completely, this dog hair is really pissing me off, that said that it was completely safe to lick lead. They had a researcher just fucking going down on this lead. I saw the video. Why is nothing soldering? Why do you not solder? Why do you not solder? The soldering iron says it's on. It's just not helping me at all. I'm going to do a big blob of solder on the end of the iron. Meetings, good luck with your soldering. Thank you. Have fun with meetings. Meetings. We got to come up with a plan. Then we got to execute the deliverables with synergy. Is that on? No. Coldest solder joint known to man. I think the tip's dirty. My filthy tip is to blame. Just the worst. Well, that'll give me a nice little clip right there. Using a jeweler's blowtorch to lay surface mount components. That's similar to what hot air is. Oh my God, I just can't get solder to stick to anything right now. What's going on? There we go. Got a little headway into that. You son of a bitch. You betrayed me for the last time. I think it's because the PTC is sticking up a little too far. This is going to be really hot. Ow, 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 ow. Oh, no, that wasn't that hot. Meow, 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 meow. Okay, let's try this. And then heat. Right there. There we go. Hold it steady. Test it. Ow. 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 It needs a little solder on the base here. The problem with soldering in a piece of wire like this is that it heats up the whole wire. And so I don't have very much time to solder the individual sides. Like I've already overdone it on this side. I'm trying to add a little bit of solder to add some flux. That'll stabilize it a bit more. There we go. All right, so now I gotta let everything cool down and we'll do the test again with 300 milliamps and we'll see if this thing blows with 300. I want this thing to get up to an amp and then stop working. Flying buttresses. Sorta. This just gives me a clip loop. I'm just being a little fancy there. And so that's connected. Yeah, okay, so we can set up the test of that. What? All these terms that you're bringing up. I at least know flying buttresses. Keep that isolated so it doesn't make everything completely explode. And then let's get some alligator leads. And I can clip from power to... Well, that's going to be difficult. I should have left a pin on this. I guess we're doing the 400 milliamp test first. Yeah, whoever decided to call them buttresses, good on you. Actually, this should be the ground. And then we'll do yellow for power. Measured power. And what we need to do is we need to go through the probe leads. So the yellow goes to red. When in doubt, clean your test setup up. There's no point in being a slob. And slobbery leads to bad results. Hey, thanks for hanging out, Katronics. It seems like you stream. If you stream, you can promote your stream. I don't care. Ow! These alligator clips suck. The spring on them is so difficult to operate. Shit. It's so difficult to operate. Like, the spring doesn't let it open up, and when it does, they go cattywampus and go all stupid. I don't know if they actually stream. It just seems like they do. I could be lying out of my teeth. through my teeth. Oh, there you go. Yeah, check out Ktronics. Okay, so amp, DC amp, DC amp. The leads are set up. This should be cool from soldering by now, right? It seems a little toasty still. No, that's pretty cool. It's just this latent heat and everything. This thing is and of course, the giant magnet on the other side of this thing attracts literally everything on the desk. So annoying. I'm just trying to get the whole test set up on camera. All right, so this should be a 400 milliamp test, a little over 400 milliamps. And let's see how long this thing, this circuit protection element lasts. 500 milliamps, geez. I don't know how well calibrated my machine is. Now, we know this thing should be good for pushing 500 milliamps, 600 milliamps the whole time. The 7805 is heating up. I don't know why the 7805 would be heating up, but then also the diode is heating up. Of course, my resistors are also heating up. My circuit protection element is cool as a cucumber. Cool as a cucumber. That thing seems to be doing just fine. Huh. How hot are we getting over here? Okay, so a little over ambient. It's really not debilitating temperatures. I want to let it run that for a little bit for each test. So we'll be done in like a couple minutes here. I'll probably end up using this one though, because if this thing is pushing 500 milliamps and nothing bad is happening, that means that it can do like an erroneous circuit for a little bit without rebooting the whole system. So if I have something that's nearly shorting out my power supply, hopefully it won't totally, well, it actually might totally reboot everything, but at least we know that this thing can handle quite a bit of current coming out. And we know that our PTC won't go off if we have too much current running for a long time. 500 milliamps is going to be kind of an upper limit of something that's sort of failing. What happens if you short it? I don't want to short it right now. I need to look up what the specs on this thing are. I don't want to damage everybody. But I may have to put a shunt cutoff on the, what do you call it? On the metered power supply, in case I plug something in with a short on it. Dan Manko, thank you for subbing with the Prime. Hey, thank you so much. Yeah, I was just kind of thinking that if I plug in a module that's got a short on it, just hopped in today, happy hacking. We got a ways to go, man, until I put together. I expected to get a little further along today, but the power supply needs to be like a nice power supply. Probably should have just bought a nice power supply, to be honest. A small glass fuse. I don't want to have to replace a glass fuse. I think maybe just like a shunt with a MOSFET on it would be enough. All right, so this thing is not heating up at all at 0.5 amp. I mean, you can see where the heat is. It's good for this amount of current, which is like a heavy load case. What are you doing? Where's the puppy? Where'd you go? Wait, I just heard the puppy. Where'd she go? Willow, where are you? I definitely heard her come across the floor. What? Puppy. Am I going crazy? I definitely heard the dog come all the way downstairs. That was weird. Okay. I don't know what's going on there. I definitely heard her. All right, so back to this. Hold on, I'm going to see where the puppy is, because I think she might be in the other room. Hey, puppy, where are you? Can you come here? Willow, come. You know, I think she came downstairs, came up behind me before I could get the camera retrained, looked at me, and I made loud noises, so she ran off. She comes downstairs to actually get away from all the noise of upstairs, so I guess I violated her trust by making a bunch of noise. Everything is warm. All right, so now we're gonna up that by a third. Well, I want to let this cool off a little bit. You can see how much heat the heatsink is actually bleeding off from the rest of the resistors. I've set off these little circuit protection devices on a couple of occasions, but it's not very often. I feel like they're not doing anything in most circuits. All right, here we go. Higher current. Oh, come on. I hate these alligator clips. They have a rounded clip end, right? And it's rounded this way so that when you pinch down on it, and the spring is of course way too taut, it twists in your fingers because your interface is this slippery plastic. These are very cheap. All right, 800 milliamps. Here we go. Honestly, why do I even bother with these circuit protection elements if they're not going to do anything? It seems like the diodes will explode before anything else happens. If you look at how hot they're getting. What is the fucking purpose of these stupid things? Eat soldering iron, you bastard. There it goes. So there's where it actually triggers. So if it were on fire, it would actually trigger. I had to get a 600-degree soldering iron right up next to it in order for it to do anything. So now we cut off and let it cool. Those are capacitors, they're firecrackers. That was one of the pieces of advice from that Troubleshooting Analog Electronics book, is that if the capacitors are the size of shotgun shells, then they can dissipate as much energy as a shotgun shell when they burst. So you got to be careful around them. Patented desktop dynamite. Yeah, does it need to be closer to a heat source? Do I need to put it on top of the power supply to make it artificially get hot enough? I mean, 600 degrees is a pretty intense amount of heat. And when these things are on circuit boards, they're not near anything. Honestly, I got that one off of this. I got it off of a test board. It came right there. That's nowhere near the processor. On this yo-yo board. Got it from right there. All right, so let's go back to high current. We're kind of beating up this little unit right now, but this thing is taking it all in stride. It's doing really well. It seems like they would need almost a short to trip. And my diodes are going to break before that. Super high current, 1.3 amps. I'm burning my load resistors. Burning my load resistors. At least the component is getting warm. Well, because they're not supposed to... Oh, look. We triggered it. So if we draw over an amp, 1.3, 1.4, I think it was, then we will trigger the PTC. Now, obviously, this thing didn't have time to fully cool down. It only mostly cooled down. So it's possible that, you know, it would take a little bit more. But if we get to 2 amps, we know that it does trip, which is good. Of course, might be hell on the rest of the circuit, but so be it. This is a test device. everything is in a socket, so they tend to allow damage to occur before they're useful. I think in this case it won't. Well, it would allow for a little bit of damage to whatever's already broken, but I don't think it would further damage whatever. What I basically want is for something that's already broken to not blow up my power supply. So as long as the power supply can tolerate being a 2 amp device for a little bit, which this thing can, we've seen it do it multiple times, then I think we're good. So in this case, I think it will actually be an adequate prevention device, an adequate damage prevention device. In something like this, I don't really think it's very justified, because this thing is so sensitive that if you accidentally put 12 volts through this thing will take a little while to stop. I'm talking about them like they're two different ones, it's the same one. 1.3, generating steam heat. Something. Lynn Street, pop. Let's go. Shoot him in the back now. Dan. What we want, I don't know. Hey, circuit protection. Look at that. So we are unable to run 1.3 amps for an extended period of time. Pretty cool. And it is a slow blow. Not a low blow. That's a different movie entirely. Okay, so I guess the really tiny PTC is going to be really good for the rest of our circuit. That said, I guess it's closing time. I've been streaming for, checks watch, 4 hours and 30 minutes. It's kind of short. I would like to do longer streams. The weather's cooling down. I'm starting to get more sleep. I still have massive dark circles under my eyes. I will handle it eventually, but the USB will handle 2 amps and it will cut out at 1.3. That's not the USB. That's the PTC. That's this element right here that's cutting it off. The USB can handle like 5 amps. It can handle like an incredible amount of power at 15 volts. So it's not the USB, it's the PTC, the silicon whatever protection device. And it is not a completely super accurate. I mean, having like a current sensing shunt that shuts things down is a much better way to do it, and that's the way like these power supplies do it. If it draws too much current, it'll drop the voltage down and protect your device. But I don't really have the means to put up that kind of electronics on this thing. This is a 75 watt USB-C power supply. Let's see what kind of shape it's in after all that. This is what I power my oscilloscope with. This is an Anker GAN Prime. They're using gallium arsenic to promote their devices, which is funny because transistors have been giving you the formulations, calling it gallium arsenic, trench FET technology. They're starting to steal some of that marketing, which is hilarious. Anker 73S 65 watt. Yeah, this is the one that Amazon accidentally sent me instead of a dog toy. It's supposed to be like a $10 dog toy, and I got a $75 laptop charger. So this thing, since it's the nicest power brick that I have in the shop, goes to the scope. The nicest power thing you have, use it on your scope. So that's what I'm using. I have another plug on it, so I might as well make it plug into this thing and power it. Amazon loot box mechanics. I know, you can order a million things from Amazon, and I do, and you will only get one of those. By the way, the comedy of this thing is that it came with a whole suction cup thing. You can put a little suction cup thing on this, so it'll stick to your power outlet and not fall out. Yeah, GAN Prime, gallium nitrate, which has been used in FETs for centuries now. They've just decided to make it part of the marketing. So I figure that all of the good power and protection and stuff is in that thing, which is why I'm using it in this power supply. So I'm going to let this thing cool off, and maybe I'll do another test, but it seems like we could do 1.3 amps for a little bit, and then it'll cut out power. Are the millions of tons of shit from Ali? Not literally. So you order hundreds of tons of literal shit? I went looking for USB-C power supplies, and a lot or almost all of them are labeled with GAN. Why? That's so weird. All right. Yeah, like literal manure. I have modules sitting all over the desk, and we're gonna have to start organizing them onto the PCBs. I do not stream on Tuesday or Wednesday. I don't stream on Wednesday because I allow, that's the allowance for shipping in case I need to order something like that we absolutely direly need. We got this close for me needing to order something, but apparently that smaller circuit protection device is all I need out of all of this stuff. I will be back on Thursday, and I need to set my commands. I keep forgetting to set my commands ahead of time, which is the 5th. Let me just set the commands so that it looks like I have any semblance of production value out of the stream at all whatsoever. I need a way to auto set these. I don't know how to do that. Go over to my secret admin channel. Edit com next. Nobody uses these anyway, but I still set them. People used to use them when I was popular. Back when I was popular and I was on the football team. No, back when Burn the Subs worked and there were more people around. We'll get Burn the Subs up and running. You know, it's always a thing. But it's a big draw of users to this channel. Whoa, what the hell is that? What is that weird? Oh, the x.com. Twitter.com automatically turned over to x. Here, wait, yeah, the fart box is something. Am I in Discord? Yeah, there's actually a Discord command or a link that's just about to pop up. And I'm on Discord more than anything else. I coordinate everything via Discord, and you know that's just what we use for everything nowadays. Yeah, there's a link, and here's the end card. That one translated to Discord, but for some reason on Discord, the client, it translated Twitter.com to like some weird characters that looked strange. I don't know, but that came through all right in there, and that's a clickable link on Twitch if you want to. But yeah, I'm on Discord more than anything else. I mean, just the other night, Flatulent Gonad and I went at it again with weird, like 80s and 90s music, which is usually it means that I'm drunk, but there was a lot of very interesting tracks in there. I even sent it to another friend of mine, and he's like, that was actually good music. I'm like, yeah. It's weird. The world is a very strange and large place with many interesting areas. I'm going to be back on Thursday. We're going to work on soldering modules down in logical areas. Now that we've vetted out all of the components of the power supply that I need, we can just continue to build the circuit now. That was sort of the last thing that I wanted to make sure went over good. And then in the future, hopefully, I'm going to have enough room on the board that if I want to build a cutoff, like a shunt cutoff that says like, oh, 2 amps, cutoff, boom, I will be able to put that in. It's just you put like a MOSFET and an op amp in there, and you just compare currents, and then when it's over current, it'll cut off the MOSFET. So yeah, we may include that at a later date. I'm going to try to keep scope creep from killing this. Now, the sun's almost down. You can see it's getting darker out there. It is a beautiful day out. I want to go touch grass. I suggest you do the same, but if you want to join me on Discord, the links have been in there. And I will catch you guys Thursday. Yeah.